Hi, and welcome to the course, Build Your First Web App here on Microsoft Virtual Academy. You might be here for one of many reasons. Maybe you have a great idea for an app that you want to build, but you have no idea where to start. Maybe you have some programming knowledge, but you've never done anything for the web. Or maybe you're just a lifelong learner who wants to pick up something new and learn what web development's all about. And if any of these things are true, then you've come to the right place. I'll be your instructor for this course, so let me start by introducing myself. My name is Brianna Dean. I am a content developer for the Microsoft Learning team, where I create online courses like this one to teach computer science and prepare students for careers in software development. I love teaching computer science so much that I also volunteer teach at a high school here in Seattle before coming to work every day. And I've received my bachelor's in computer science from Georgia Tech. Go Jackets! And prior to joining my current team at Microsoft, I was a software engineer on the OneNote team. So I learned computer science in high school. That was my first introduction to it. And it wasn't the greatest experience at first, and that's kind of what kickstarted my interest in teaching computer science, because I love teaching it in a way that excites and engages more people. So I hope you enjoy this course. So let's talk about what we're going to learn. First up, we're going to start with how to determine what you're going to build and why. So we'll talk about how to identify users and the target audience for your app and things like that. And then we'll go into how to actually build web pages. And we'll learn a language called HTML. From there, we'll learn how to add style elements to those web pages using a language called CSS. Next up is manipulating web content, so that's adding behavior to web pages, and that's using a language called JavaScript. From there, we'll get into some back-end web development concepts, and then we'll learn about databases so that you can store data for your app. And finally, we'll learn how to put your app out to the world using Azure. So by the end of this course, you'll have designed an app for something that you're interested in. You'll learn how to build it from scratch, and you'll have it up and live on the internet for other people to access. Now, those are a lot of topics to cover, so the purpose of this course isn't to cover each of these topics and languages in detail. That would be a lot of content. Instead, you should approach this course so that you can get an understanding of each of the pieces of building web apps and be able to build upon that knowledge from there. So we actually have some other courses that would be a good next step from here. They're listed here. These are our courses on edX.org, and they'll be linked in the resources for this course. So the first course is Designing a Technical Solution. That will cover a lot of the user-centered design, HTML, and CSS principles that we talk about in this course. Next is a course called Building Interactive Prototypes Using JavaScript, and that will cover all about basic programming in JavaScript and client-side development. And then we have a course on building functional prototypes using Node.js, which will cover all of the back-end web development concepts. So I'm glad you're here, and I'm excited to teach you about web app development, so I'll see you in the next video. Welcome back, and welcome to Module 1 of the course. So we know we're here to build web apps, and you probably want to build something that people will actually want or need to use. So in that case, you should start by planning and figuring out who will use your app and why they will want to use it and how you'll make sure that you add value to them. And with me to talk about this, I have my coworker, Adrian. Do you want to introduce yourself?
I would be happy to. I'm Adrian. I'm also a content developer here at Microsoft Learning, and my expertise is kind of in the design thinking, user-centric design field, so I'm happy to be here and talking to all of you.
Cool. So as I mentioned, the first thing we'll start with is figuring out who our users will be. But before we do that, let's just define what exactly it is that we're building in this course and what a web app is. So an app in general, first of all, is a software program that allows a user to complete specific tasks or achieve specific outcomes, right? So two things that stand out from that definition is that it has to be user-centered, right? You want someone to be using the app on the other end.
Sure.
And it runs on some sort of device. And that distinction about what device an app runs on is what makes it a web app or a mobile app. So in this case, we're focusing on web apps, which means that we're creating things that a user will access via a web browser. And that's really common nowadays, right? With the internet being so widespread.
That whole internet thing.
Yeah, people can access your web app from their mobile phone, from their desktop, from any device that has a web browser. So now let's talk about who those people are that will be using our app. How would you describe user-centered design? Like, what's the foundation of that?
There are two main principles. I think you know what they are because they're on your slide. But those two are user feedback and iteration. And these are two things, a yin and a yang, that can't exist without each other. Because to iterate, we need to know what the users think.
Right.
And to actually find out what the users think in a meaningful way, we have to make something new for them to look at. So it's user-centric design is a cycle between building something, showing it to the user, and then taking feedback and then improving upon your original design.
Right. So you don't want to spend like a year building something in isolation and then show it to your users and see what they think, do you?
No, it's all about rapid iteration, rapid prototyping, and most importantly, rapid failure. You have to sort of learn to embrace failure because every time that we fail, we learn something. And those discoveries can lead to the creation of a better user-centric app.
Cool. So before we can build something to show them, we kind of need to figure out what they need, right? What we can build for them.
Sure.
So as we're designing and building software, you kind of want to create a user experience that it draws people to your app. And the foundation of that, as represented in this pyramid that you see here, is something that satisfies the needs of your users. So that's why we're going to start with user needs in this module and figure out, talk about how we can figure out who our users are and how we can address the things that would benefit them. So how do you figure out who your users are and what their needs are? What are some ways that we can talk to our users and figure those things out?
Well, most of the methods can be categorized in two categories: quantitative investigation and qualitative investigation. The most common in the quantitative category are user interviews, sometimes called contextual inquiry, where a designer will go into an environment where the user is doing whatever they do and just observe them and sort of look for pain points. Do they have to work around something? Was something difficult for them to do? And that'll inform our decision on how to pick a problem that we want to solve, really, because that's what this kind of comes down to.
Yeah, and I think some people don't realize that they can simply go to where those people are and talk to them and observe them. People think that we have to do these high-level, research methods when really it's all about the user, so you really want to be with them as much as you can, right?
That's true, and I think one of the most important things that we can stress right now is get out of your office and actually go talk to users, because that's how you learn, that's how you get better at design, and that's how you ultimately make a better application.
Right, and then another way to, once you've done this research, to kind of synthesize that information and figure out, your high-level groups of users is to create what are called user personas. And that allows you to kind of think about all of the things you learned about your user and create a fake persona that will represent all of the important information that is relevant to how you'll address their needs.
Sure. Like you said, the user's not going to be in our office working with us all the time. So we need to create this user persona that we can consult when we're not actually able to speak to the user.
So that's kind of how you can start with identifying user needs and synthesizing them and making sure that everyone who's working on your product knows what you're going after and who you're building for. And in the end, the goal here is to identify your value proposition for your app or your product. So that is, you should be able to, at the end of this process, summarize who you're targeting and what value you're bringing to them in a single, succinct statement, both for yourself so that you know what you have that in mind the whole time, and both for the users who will want to use your app. So that's the end goal.
Right, and these statements are sometimes called how might we statements, because they combine the user, who they are, and what they need to do. So you might say, how might we help airplane commuters get through the airport more efficiently? That sort of encapsulates who we're talking about and what we want to help them do.
So the essence of what we talked about so far is that you should be building what people need and not what you as a developer want to build or what you think people will need, but what people actually need based on user research and actually getting in front of your users and talking to them.
Hey everybody, I'm Ian Micketzell. I'm a product manager on the OneNote team at Microsoft. I studied usability design at the Rochester Institute of Technology in Rochester, New York, and I've been at Microsoft for 6 years.
And I'm William Devereaux. I'm also a product manager on the OneNote team, and I went to school at California State University, Sacramento, where I studied computer science. Now I've been on the OneNote team for about 3 years, where I lead all of our Windows apps. Ian, can you tell me a little bit more about what it is to be what it means to be a product manager? What do you do?
That's a really good question. Product managers are essentially CEOs of the product. And so that means we wear a lot of different hats and we do a lot of different things. But overall, we need to determine things like the product strategy, what we should build and how we should go about it. We need to think about things like the roadmap and prioritization of features within that roadmap and determining what we build. So those are some of the things that we do as product managers.
Yeah, it's always really important we're kind of, like you said, we're the CEOs, so we have to look at the whole thing end to end, and we talk to customers, we work with the engineers and the designers and marketing and support, and really make sure we deliver a complete experience end to end by the time it reaches customers. And so I think it's a lot of fun because we get to wear a lot of hats and do a lot of different things.
Yeah.
And really get to experience all the different parts of the whole software development process, which is really cool. One of the big aspects of our role is customer engagement. This has been a huge area of focus for the OneNote team in the last year and a half or so.
Definitely.
And so, do you want to tell some of the unique things we've been doing that we didn't do it previously, and now I think it's really helped the team a lot. I don't know if you have anything
Totally.
to share.
So some of the things that we've done since turning into a more customer-centric focused product is really getting out in the real world and understanding what our customers want and need. And we do that both through the real world, like going to, for example, for OneNote, we're focused on education, so we go out to schools and we do a lot of customer visits in person. Mm-hmm. And so I've done a bunch of that personally, and want to talk a little bit about like the things we've learned from that. And a lot of times we actually use the power of the internet and we go out on the web, and just there's so many places these days where people can provide feedback on a product, right? So there's things like YouTube, there's things like Reddit, there's so many online communities that you can go to.
Store reviews.
Store reviews, App Store reviews is another big one. And so I know you've done a lot of that as well, and looking at the totality of the feedback and figuring out what we should do based on it.
Yeah, we get a massive volume of feedback.
Yes.
It can be overwhelming at times,
Yes.
But it's good. We like hearing from the customers and talking with them. And I think as you said, we'll be online all the time, looking through the forums, reading reviews of the product. There was a time right after we shipped our Windows 10 app where we knew there were a couple features that we didn't quite have yet that we wanted to get added.
And our users knew this too.
Our users also noticed it, and so. I think over a 2 or 3 month period, I responded to every single review that someone left us in the Windows Store.
Yeah.
And every single one. I reached out to them and said, hey, thanks for using our app. I want to hear what you like, what you don't like. And then we had this one-on-one engagement with every single person. People that had issues, we actually connected them directly with the engineers. Not some support team off in some other part of the country or the world, but our engineers who sit in our building. And
that's a really good point, because one of the things that I think is a common perception when I go to schools and talk to them about product management or working at a tech company is, oh, so you just write code, and that's what a computer scientist does. But we both went to tech schools, we have tech degrees, yet we're not writing code day to day. We are doing the other things that make a product, right?
Right,
so,
right.
And again, it's not just designing either, right? People think of the classic thing like, oh, there's a design and then there's people who build it. But pre both of those things, you need to have someone who says what should be designed, what should be built. And that's really what we do, right?
That's exactly correct. I mean, I'll provide feedback on the design or on the code. I'll say, hey, we could try this or that, and give my ideas. But when it comes to those things, I actually don't do any of the work myself. Right?
Yeah.
We have specialists who are they're skilled engineering or design or marketing or whatever, and so we actually just get to partner with all of those people and make sure that the end result meets the goals and the needs of our users.
And I know another piece that we wanted to talk about was this notion that there's, in the world, we talk about it as qualitative and quantitative information, right?
Yeah.
The qualitative is the numbers. It's all the data of the feedback and the metrics, and there's business metrics, like how many monthly active users we're getting, but then there's lots of kind of telemetry-based like data on crashes and bugs and things like that.
How often does someone click a feature, all that sort of thing.
Right,
Yeah.
and we have great data scientists these days, and that's a whole other field in technology you can go into. But as product managers, we kind of sit on the other side of the fence, and we really focus on kind of, I would say, the qualitative, the kind of art of it, right? If there's a science half to it, there's an art side of it. The quote I love, right, is Henry Ford, and he used to say, like, if you just asked people what they'd want, they'd say faster horses. But they didn't know that a car could exist.
Right.
And so what I was going to mention was when you went through all that feedback, part of your job, I think, was to actually prioritize and figure out what should we do with all this feedback. It's not just about answering everybody individually, but it's about kind of correlating all of that together to mean something, right? To figure out what the plan should be.
You're 100% correct. I mean, a lot of times people will say, I want feature X. And you could just go build it, but that's
it doesn't scale.
It doesn't scale, and it's not always what they want as well. And so what you really have to do is think about, okay, so what was the intent of the user? What are they trying to do and that they're struggling with? And sometimes it is exactly what they wanted, right? For example, if they want to be able to highlight text, maybe a text highlighter is probably the right thing to do. But if maybe they're having issues with constantly bumping something in the interface, instead of just fixing that particular issue, which is important to focus on, so you're not actually bumping the page list or something.
Right.
But maybe they want a special full screen mode where they can ink and without any distractions and have easy access to all of the things they need, all the tools. And so it's really like thinking through and figuring out, okay, what do they actually want? And as you said, it's kind of an art. We definitely rely heavily on the science side as well, like the data, right? To tell, like, do people use a Git feature? If they don't use it at all, well, chances are we probably shouldn't, build it or something similar. And there's a lot of different things.
I think we wanted to wrap up by telling a couple real examples or stories from our own experience of kind of how we took input from the real world as product managers and made it a reality, made a feature out of it, right? And so behind us, you actually see this is one of our Surface Hub products. It's an amazing large screen device, and it's running OneNote, our Windows 10 version of OneNote. And you'll see there's digital ink written on the screen, but one of the things that you see there is what we call rainbow ink. So the ink actually looks like the colors of the rainbow. And this was a super interesting project that I was able to lead, and it came out of doing those customer visits to a school. And I went into the school, and I asked the class, I said, if you could have ink do anything in the world, what would you want, right? And I remember this so vividly. There was this girl in the back of the classroom, and she was very they were a younger class and very timid and a little afraid to speak up. But she raised her hand and she said, I think it would be cool if the ink looked like a rainbow. And immediately the rest of the class erupts, right? Like they're like, ooh, oh my gosh. Yeah. And so I put that in the back of my head. I went back to our design team and our engineering team, and I said, guys, this is what we have to do. There's something here, right? Like that reaction is the art. That is the thing. I didn't need to see 1 million users of data. All I needed was a small sample set of kids' faces, right? And so I took that back to the team, and then it was a fun process working with design. We actually were able to create 4 different versions of these ink effects. So you're not seeing them up here right now, but there's rainbow, galaxy, gold, and silver. And since we shipped it this summer in OneNote, it's just been one of these things where the feedback that you mentioned has just been through the roof. Like people find it really fun and engaging. And I like to tell this story mainly because it's a really good example of product management, both taking a small nugget of insight, but also I would say bucking the trend in a way, because this was something that was not on our radar for the product roadmap. And we were able to be agile and just be receptive to the information we got and actually change our course, and for the better, right? Like this produced a feature that was really valuable. But it was a fun story, and I like to share that with folks. So it's a good example.
And I love that we were actually able to build this, because I mean, there were even some people who kind of doubted, is it really that important,
Yes.
on the team? But the feedback has been phenomenal.
I forgot the one part of the story I love to tell, which is the first day we had the prototype of this. You're right. If you think of the boardroom setting where people are using OneNote for their meeting notes, there were some doubters about, would this make any sense?
Why would you use rainbow ink?
Right, right. And the first day we had a prototype, I walked into an executive meeting and I just handed the rainbow ink to one of our execs and didn't say anything. I just gave him the pen and saw him start writing with it in the middle of the meeting, and his face went from this to this. And it was the only thing I needed to see, right? It was the best reaction. So
exactly. And even we go to conferences all the time and talk to customers, teachers, students, all sorts of our users. And this is consistently one of those features. Just their eyes light up when they see it demoed, and it's so much fun.
It's a demo pleaser.
It really is. Yeah. But it also works in the real. It's not just like a flashy thing on the screen. When you're actually using the product, it's exciting as well.
And I know you have an interesting story to tell too.
Yeah. So one of the, like you said, we get to go on customer visits and meet people in person. We get to go to conferences. But sometimes, especially if you're still in school or something and you're working on a project, you can't necessarily go out and meet people. It's a little bit harder. You might be able to go to a coffee shop and talk to people and maybe show them something, but it can be a bit harder. But you can still do it from the comfort of your own home by engaging with users online. And we kind of talked about this a little bit earlier, where the whole team actually engages with customers and provides support directly to them, which is fairly uncommon, I would say, where you actually have the people who actually build the product working on it. And so it was that time when we were responding to customer reviews through the Windows Store. I think we almost broke the tool. We responded to so many users over such a short period of time. But we got fantastic feedback, and the ability to engage one-on-one with these users just over email was amazing. And we're constantly on Twitter as well, responding to users there. And
that's important for folks listening to this, right? Because you don't have to necessarily find a real-world place you can go. We have the power of the internet and power of communities online, and you can learn a lot just by trying to listen and observe what is going on. And that was the last part I was going to mention, was it's the observation. It's the taking in of the input. Don't necessarily take every word exactly what they say, but be able to listen to what's being said and interpret what that might mean if you're designing a product.
Exactly, because it's definitely difficult you have to take all these different sources, all these different inputs, and then when you're done, actually prioritize a list and figure out, okay, now what do I actually need to go build? And that's the trick, is figuring out which sources are the most important, or which ones have the most weight given the current dynamics on the team. It could be something that's very critical that you need to do, but we can actually do it in 6 months, versus something that maybe needs to be done more immediately because it's more of an urgent issue, or something that will drive the business.
Welcome back. Still here with Adrian. So at this point, we've talked about how to identify who your users are and what problems you'll solve for them. And you might be tempted to just, once you know those problems, jump in and try to figure out what your app will look like and what features it will have to solve those problems. But it's important to slow down and really make sure that throughout that process, you have users in mind the entire time, and you take it step by step to figure out the best way to address their needs. So we'll talk about how exactly to identify and define the user requirements for your app. So are requirements the same thing as features, or what exactly does it mean to define user requirements?
Well, I think requirements have more of a nebulous definition. It's more about, what does the user really need? I think a feature solves a requirement. A feature gives you the opportunity to get over your requirement, right? But I wouldn't say that they're the same.
Yeah, and then in software companies, we typically define these requirements in a document that we refer to as a spec. Really is a requirement specification. And in that document, we kind of talk about, there's two kind of broad categories of user requirements. On one end, there is, what does the user need the app to do for them? So we talk about what the software will do. And those are referred to as functional requirements because it's functionality based. And then we also have the softer side of things is how much do they care about how fast it is, or how much do they care about, how accessible the app is. And those are non-functional requirements that focuses on the qualities of the software. So you want to kind of think about both of these, but for now we're going to talk more about functional requirements and figuring out the functionality of our app. There we go. And what's your favorite way to define user requirements? There are a lot of ways out there, so what do you think is the best way to approach this?
Sure. Well, coming from a user-centric design perspective, I really enjoy the user story, which is essentially a way of getting to understand who the user is and what they need in a way that's a little bit more personal than something like a system requirement, where we're just talking about what are the different features that the user might need.
Right.
We're trying to understand the user a little bit better, and then maybe we can make some choices that we wouldn't be able to see or even understand if we didn't really know the user.
Right. So just to walk through a couple of these types of requirements, system requirements, as Adrian mentioned, kind of focus on things from the perspective of what your software will do. So you might say the system should accept input for user accounts, something like that. And that's just focusing on functionality in a really specific way. Use cases are pretty thorough, and you kind of break down how a user will encounter a certain scenario with your app, what will happen throughout that scenario, and what the outcome should be. So the good thing about use cases is that they lend well to the development phase because everything is pretty well laid out.
Sure.
But I also prefer user stories because they won't change as much. You know what the user wants pretty much, and you're focusing on what they want as an outcome and not necessarily how you're going to address that. So an example might be what kind of app could we talk about? Like as a student, I want to
buy and sell textbooks.
Yeah, so that I can make money or make the most of my resources, right? So you want to make sure that you talk about what their end goal is and why, because those will really help you make the best decisions during your design and development phase. And the end goal here is or the thing to keep in mind is that users don't always know what they want. So you can't just take everything a user says for face value when you're in your research and interviewing phase, because as we kind of talked about, users know the outcome that they want, but they don't necessarily know all that's possible for how you can address that. So in the next video, you'll hear more about how you can kind of interpret user needs based on what users tell you, and you'll hear from product managers at Microsoft who do this on a regular basis.
So one of the most critical things that we have to figure out all the time is when somebody tells you something, do they actually mean that, or do they really want something else?
Right.
You have an interesting example of this, right?
Yeah. So for Windows 10, we released it when Windows 10 came out in June of 2015. But there was a lot of feedback. So we had an app on Windows 8, OneNote app on Windows 8 that had a radial menu, which was like a circle and with a bunch of commands. And it was cool. It looked great. It was fun to use with a pen, but there were a number of issues with it. It didn't scale well. As we added more features, it got really cluttered, and you'd have to like dig under multiple layers, and you wouldn't necessarily know that. Right. Oh, to get to font color, I have to click on the edge of bold or something. You wouldn't think that. And so we redesigned the interface and came up with what you see here. But there are a lot of people who still love the radial menu, and so that was probably.
And they actually were like super passionate about the fact that we took it out.
Yeah, they were very disappointed, and it's hard for us because we loved it as well. It just there was a number of reasons why we just couldn't continue to use it. But if we had been listening directly to, if we were just taking what customers said at face value, we would have just built the radial menu and called it a day. But that wouldn't have worked for a number of reasons. You would have a radial menu plus the ribbon, and
And I think that's what you're highlighting is this notion that a product manager oftentimes sees the product in a way that the users don't, and we know more kind of the guts and what's going on inside the product, and we also know where we want to take the product.
Exactly.
Right, and so those are inputs that a customer or somebody that our audience may be talking to The folks that you talk to in a coffee shop, they have no idea about those. And so you have to kind of take what they say as one input, but not the only input, right?
Right. So then the problem we had to solve was, okay, people love the radial menu because it's fast, it's easy to use. How do we make the interface just as fast? And we kind of looked through everything and we came up with a full screen drawing mode so you get all your commands right away. And we got to a spot that I think was pretty good, but there was one key piece that was missing, and that we believe was the custom pens. With the ribbon, you could have multiple different pens. You customize the thickness and the color of each one. And we didn't have that today when we switched to this one. You could change the color, you could change the thickness, but you couldn't save that.
Right.
And so we believe was like what the users really wanted. It was those custom pens, and not the radial menu itself, which also had there were nice things about it, but it wasn't the fact that it was round and small that people wanted. It was the fact that they had those custom pens and it was fast and easy to access. And so it's that kind of thing, or really teasing apart like, what do the users actually, why do they like that thing? Why are they asking for it? And I think there's a great quote by Henry Ford.
Yeah, like he used to say, if I asked people, Henry Ford, right, the founder of Ford Motor Company, if I asked people what they'd want at the time, back in like late 1800s, early 1900s, they would want faster horses.
Right.
They didn't know that, we were trying to build a car.
Right.
And so you have to, again, take what people say and then think about it more deeply. What do they really mean when they tell you something?
Exactly.
Welcome back. So now that we've talked about how to identify the needs of our users and define those requirements and figure out what features our app should have, we can start getting into designing the user interfaces for our app. So how the user will interact with our app to achieve that functionality. So first, let's talk about what is a user interface. What does that refer to?
That's a very broad question. But a user interface essentially is just what the user interfaces with. Mm-hmm. So what do they touch? How do they interact with the application itself? And that can be something from a scroll wheel to a button that you might click to maybe touch controls on a mobile tablet or something like that.
Right. And in this case for web apps, our user interface would just be those web pages that users access to interact with our app. So some things to keep in mind at this phase when you're designing user interfaces, back to our user-centered design approach, we want to always be iterating and getting things in front of users quickly. So we want to prototype our app without focusing on too much detail in the beginning, just to make sure that what we're thinking works for our users. So some things to keep in mind is design as quickly as possible. Don't waste any resources or too much time. Sketching is good at this phase. Get feedback and iterate. That's going to be kind of the process of designing at this phase.
Yeah, and I think one of the most important things that we can stress is do this all quickly, because it's all about rapid iteration. If the user doesn't like something, change it.
Right.
And then show them the new version. If we spend, months and months creating this perfect application that we think is great, and the user ends up not liking it, then we've just wasted a bunch of time. So, like you said, don't focus on the details, how it looks. These things are just going to be distracting for the user once you talk to them. We're much more interested to know if we made an entirely redundant page rather than whether or not the user likes the blue color that we used.
Exactly. So with that in mind, the thing that is most important to identify first are the things that everything else will be built on top of. And that's kind of the core functionality that your app will have and how users will interact with that. So with web apps, we kind of want to keep in mind that users will be performing actions with information, right? They will be inputting things, viewing data, modifying and deleting things. So you want to think about which of those operations your app will emphasize and how you can support those operations with your app. And from there, you can start designing the layout at a high level to support all of that functionality. And then at that point, you can add the finishing touches on top with color and style and all of those visual details. So one way to start with that interaction is by doing what's called interaction design. You identify what requirements your app will support, you figure out what visual components and layouts can support those features, and then you can just sketch out a high-level visual to depict that interaction. So let's look at an example of how this will look with Adrian.
Sure. So let's say, for example, that I want to create an email application. Fairly simple. I would assume that everyone knows how that works. Essentially, you can receive emails, you can view your emails, you can send them out. Maybe there's some other features, but let's just focus on the simple ones as of right now. So typically, you want to start with a landing page or your home page. So we'll start out with a simple rectangle that represents our home page. And maybe on this home page there is an inbox button, and there's a compose email button, and there's a check your drafts folder. So there's a bunch of different buttons that will take us to different pages. So let's say, for example, we have an inbox button over here, and that'll take us to the inbox page. So you can kind of see generally what we're doing here is mapping out the style and the structure of our application by representing each page with its own little box. So let's see. We also want to have a compose email button. So from the front page, maybe the button is down here, and it'll take you to the compose email page. So now we have our inbox, and we have our compose email page. But sometimes if you need to respond to an email, there'll be a reply button in your inbox page, right? So interestingly, a reply is just composing an email. So we'll see, maybe we have a reply button here, and that'll take us all the way down to our compose email page. And you can sort of see that as you get more and more into the details of how your design will look, you can start seeing that these maps will get a little bit more complicated as you go on. But keeping it simple with just boxes and maybe some very rudimentary button icons, you will be able to create something and see how it looks and keep it simple without actually going into huge amounts of detail.
Right, and this is pretty easy. You see how quickly you were able to do that. It's a good starting point once you've identified like what user needs you're addressing and the features that you want to support in your app. This is a quick and easy exercise, and as Adrian mentioned, that's what we want at this phase. So from here, though, we can start to fill in. Once we've gotten this in front of users and other stakeholders and tweaked it as necessary, then we can start to fill in what each of these pages will look like and talk about the layout of those interfaces. And we can do that with what's called wireframes. So a wireframe, just going back to the user-centered design approach, these should be low cost, low fidelity, meaning they don't need to represent like how the app will look in its final phase. They really focus just on using lines and boxes to depict the high-level visual elements, and we don't include any color in wireframes usually. So the goal here is just to quickly sketch out what the visual components for your app might look like. So we'll continue with this email example, and let's look at what a wireframe for this could look like.
Sure. So the difference, I would say, between a wireframe and just the interaction design is that our wireframe is going to have a little bit more detail. For example, we're going to see where on the page exactly should this button be, because stuff like that is important to know early on, because the entire structure of our web application might be changed by how the user uses it. So
right, we want to figure out those structural components before figuring out
early on, as early as possible. So we'll start with a little bit more of a detailed landing page here. We'll just call our email client InLook.
Perfect.
Very creative, I know. And in this page, let's just say we want to keep it very simple. The user has 3 options. So here's a big button in the middle that takes you to your inbox. And we'll have another one for composing. And a final one, let's just say to view the deleted items, the emails that we've put in the trash can. So we have our 3 buttons, and now we need to map out what the other pages are going to look like. So in the same way as earlier, let's just use the inbox as an example. That'll take you to another page. And maybe your inbox looks a little bit more like a conventional email. This landing page isn't really something you'd see in a lot of different ones. But we'll have maybe a bar at the top that'll tell you some information about your inbox, how much mail you have, maybe a nice picture, keep it visually interesting. And after that, we'll have a series of emails in a list-like format. So we'll just, we don't actually have to fill these out with too much detail. They have all the different words and stuff in them, but we'll just say, here's the subject line, here's who it's from, and here's a button on how to view it. So we have, our inbox page all sorted out. That looks great. Now let's design the view email page. So this view button will take you down here to this view email page, and we want to decide how this is going to look. We want it to look clean and easy to understand. And the best way to do that is just to workshop some different ideas for the layout and then show them to users, see how they think. So we'll just start this out. Maybe at the top we'll say, who's this from? So we'll say, this is from my coworker Bree. Maybe have a little picture of her. And we'll have a subject line, and down here will be a box containing the text content of the email. So you see that this is a little bit more detailed, a little bit more in-depth than the interface interaction design that we were doing earlier. And this gives us a little bit more room to be creative about how our application is going to look. Now, I would really like to stress that this shouldn't really impact your final design. This is something that's going to come over rounds and rounds and rounds of iteration and testing. But this can be sort of the skeleton that you build off of.
Right.
So it's important to build something that the user really meshes with and is able to use very well.
Right, and I think the details that matter most at this phase are identifying what data is necessary, because at some point you need to figure out how to set up your database and the structure of your app. So what matters more are the components that are data-based, not to say database, but how you'll store information, what information is necessary for your app so that you can start designing the technical side of it. And what matters less is, exactly what text you'll have at the top of the page and things like that. You want to focus on the right details here so that you can figure out the most important technical pieces of your app in the next phase. And what you can do from this point as well is, if you look back at Adrian's wireframe here, you have different boxes, and you could draw each of these on a larger sheet of paper and maybe get them in front of users and actually have them click through by kind of just touching on different parts of the page. And make sure that they understand what they could do from each page without even having real words or images on the page. They should be able to understand kind of a high-level flow of what they could do with your app.
Yeah, that's really important. A lot of times there are things that we don't even think about or can't even see about our designs that might be difficult or unclear to the users. So actually going out, showing them the physical paper representation of your prototype is a great way of finding out maybe this button is unclear, what does it do? Or maybe this should be higher up on the page because the users aren't seeing it until too late.
Right, or there's not a button there and they don't really know what action they can take from your page, things like that. And we talked about sketching on paper. You could sketch on electronically like we've done here. There are software and tools out there that are made for wireframing specifically. You have a lot of options, but the point is don't spend too much time trying to ramp up doing something new. Just do what you can do quickly and get it in front of users. So to summarize, the goal here is to, as always, keep users involved in your design process. Sketch things out quickly, figure out the high-level things before you get into the details, and get your ideas in front of your users as often as possible. So thanks to Adrian for helping us with this module.
Glad to be here.
We'll see you in the next video. Welcome back. Now that you've completed Module 1, you should have a clear understanding of how to go about planning and designing your app in a user-centered way. The user-centered design process we introduced you to should take you from the idea phase through user research, and you should end up with an initial prototype in the form of wireframes. These wireframes give you a good starting point for building the layout of your app without focusing on the visual details, and that iterative nature is at the core of user-centered design. Now, in this module, we'll finally start writing some code as we introduce your very first web language, HTML. But in this video in particular, we'll start by reviewing some web development concepts and making sure you understand what tools you'll need to start writing code. One of the first things we should get out of the way is what exactly we're building and the proper terminology to describe various types of web technologies. So what is a web page? A web page is simply a document that displays web content via a web browser. So anytime you access a document on the internet using your web browser, that is a web page. And many web pages are just static. They present information to the user as is. Like the page that you see here, this is text information and images and things like that. And every time you view it, it's not changing based on any interaction that you have with the page. It might change when someone updates the files, but overall this is not a dynamic page. And since we mentioned web browsers, let's talk about what exactly a web browser is and what web browsers do for us, because web browsers are important to understand when it comes to web development. So the web browser is the application that allows users to view and interact with content on the web. Web browsers are behind the scenes retrieving the content that we request. They send the request to web servers once we type a URL or once we click on a hyperlink. They're sending those requests behind the scenes. Once they receive those files back from clients, from servers, browsers know how to interpret the code, which is HTML and CSS, to display those web pages appropriately. And in addition to that, when it comes to developing for the web browsers have built-in tools that we refer to as developer tools that help author and debug code as you're working on your web pages. So browsers play an important role, and there are several browsers to choose from. Everyone has their own preference, and there are some differences between browsers, but it's a good idea to have at least a couple browsers installed, different types of browsers, so that you can make sure your app or your web pages work and are displayed properly across browsers. So we talked about web pages, but what is a web app? So web app is, the difference is that we add functionality and dynamic data. So a web app is a software program that is accessed via a web browser and allows a user to complete specific tasks or achieve specific outcomes. And this goes back to what we talked about earlier in the first module. So when it comes to functionality, web apps are presenting dynamic web pages. So they're presenting pages that contain data that changes as we interact with it, that stays up to date automatically, things like that. So for example, Bing here that you see on the left is a search engine. That is a web app because we use it for functionality. We type something in, the web app searches for those terms and presents information to us. All of that is dynamic information that's working with the database behind the scenes. Similarly, Stack Overflow. Stack Overflow, we enter questions. Stack Overflow, by the way, is a website that software developers use pretty heavily to share knowledge about software development. So people can post questions and other people can post answers to those questions, and you can vote on answers. So all of those things that I just mentioned are functionality. We're adding questions, we're viewing questions, we're adding answers, we're voting for questions and answers. So that's the difference between a basic static web page or set of web pages and a web app, which is something that has functionality and deals with dynamic data. And that functionality that we talk about with web apps revolves around CRUD operations, and that stands for being able to create information, read, update, and delete. So as I just mentioned with the Stack Overflow example, we're creating questions or even creating answers. We're viewing those questions and answers. Users are updating that information if they want to change their question or answer, and they're deleting those things. So functionality revolves around these 4 types of operations with our data. So keep that in mind as you start thinking about the functionality your app will have. So how exactly do we program all of this? There are a lot of different layers, and they work together to create the functionality of a web app. On the front end, we have languages like HTML, CSS, and JavaScript. HTML is responsible for defining the content of your web page. So that's the first language we'll learn. And for that, we were just marking up the contents of our page and creating that basic structure of our documents. Then we add CSS on top of that, and that lets us style and control the layout and presentation of our web pages. Then we can use JavaScript to create scripts that control the behavior of these web pages. So all of these languages work together, but they rely on the HTML to create the content, and then CSS and JavaScript modify that content for style and behavior purposes. All of these languages create the user interface of the web page, or the web app, which we refer to as the client side, or the front end. Then when it comes to working with dynamic data, we need a database to store that data. So the back end of our app has this database, and then it has some code on the server that works with the database and sends this information back to the client side. And finally, all of this code has to live somewhere, and the server has to be hosted somewhere that people can access over the internet. You don't want people sending requests to your computer every time they want to view your website. So you host your website or your web app somewhere on a server, and that's how people can access it online. So we'll talk more about each of these components throughout the rest of this course. When it comes to writing our code, all of the code we write in this course will be written in a code editor in my demos. You could write code in a basic text editor, but you should think about it like writing a paper or a document. You could always write a paper in a basic text editor that comes pre-installed on your computer, but if you're writing a 30 or 50-page paper, you don't really want to have to deal with spell checking and formatting and all of that, handling font all on your own. So instead, you might use a specialized word processor like Microsoft Word. The same thing is true when you're writing code. You don't really want to have to deal with all of that on your own. So code editors are specialized text editors that make that process easier. They automatically format code for you, they complete statements and make suggestions that make it quicker for you to write your code. The code you write might be highlighted in different colors to make it easier to understand and read at a glance. And there's even a lot of plugins and integrations that extend the functionality of your code editor even more. There are a lot of different code editors out there, even more for specific languages. Some code editors are general purpose, others are for specific types of programming. The code editor we'll be focusing on in this course is called Visual Studio Code. This is different than the generic Visual Studio editor. This is a lightweight, free code editor that is available on all platforms. So you can access and download this code editor at code.visualstudio.com. As I mentioned, code editors are really helpful when it comes to writing code. And in the next video, we'll talk about another tool that is extremely helpful and useful to software developers that you should consider using as you start developing for the web. Welcome back. So at this point, you should have a basic understanding of what components make up a web app and how web apps work and are accessed on the web. And you should be set up with a browser and code editor to start writing code. But there's one more tool that's extremely useful for professional developers, and that's source control. And with me to talk about this, I have my coworker, Andrew, and we'll let him introduce himself now.
Thanks, Brianna. Hello, everybody. I'm Andrew Byrne, and I'm also a content developer here at Microsoft Learning, and I have some courses on edX as well. So I've studied electronic engineering in college, but I've spent my entire career in software engineering. And it's been a long career, and I've worked for many different companies. And it's great to be here working at Microsoft. I've been here for 12 years. My motto is always be shipping, so I'm big into shipping code. And I also love to help and people learn. That's why I'm in this group. And so it's a real pleasure to be with you all here today. And yeah, let's talk about source control.
Yes. So why do we even need source control?
Great question. So I put together this slide, been there, done that. So how many of you have been in the situation where you're writing a paper or maybe you're already doing a little bit of coding and you want to make some changes, but you're nervous about making updates to the files you've just created. So what do? You copy and paste, and you create my file 2 or my code page number 2.
I think we've all been there. And
We've all done
for
that,
sure.
and so this is not really the version control we're going to talk to today, but that is kind of what we're doing. It's the idea of managing changes to files and that you care about. I'll give you another example. If we switch over to my machine and I'll open up my browser, and if we go to a site on my machine, let's say we go to Wikipedia, and in there, take any page, maybe we're in edX, this is a course, I've done courses on edX, so if we open up their page here on Wikipedia, it's a public page, and the way Wikipedia works is a lot of people contribute to these pages, so the pages are changing a lot. And over here on a tab you see View History, and when you look at View History on these pages, you see that there's an awful lot of changes have been made to this particular page. The revision history talks about who did what to the page. So that's just another example of version control. And so it's all around us. And when you're building code, when you're writing code, it's very important for you to understand that when you make changes, why you made those changes, and be able to go back and forwards to code changes that you made, so that you can, maybe change direction in your code. And so that's what version control and version control helps you do along the way.
And I think going back to your Wikipedia example, it's a thing to point out is that since so many different people are collaborating on the same code base, or text base, maybe if someone makes a mistake and puts something that's completely inaccurate, if we didn't have that version control system, you would have to just manually go and figure out what they changed.
That's exactly right.
This lets you quickly roll back. So let's take a look at what we're talking about when we mean version control systems in this course. So this is something that most developers use, right?
Yeah.
And like we talked about, the most fundamental thing is that version control systems allow you to keep track of versions of your code or any type of set of files over time.
That's correct. And again, bringing it back to the developer space, the majority of developers in a recent Stack Overflow survey all claimed that they check in code multiple times a day. And so what is this check-in process they speak of? Well, that's source control. And also, just to be sure, the terminology changes. So source control, version control, revision control systems, they all are interchangeable, and we'll probably use the terms in this course
I didn't even notice us using them differently because they pretty much mean the same thing.
So, but there's lots of options for this, and there's lots of tools available. I mean, Microsoft has had many versions of tooling in this space. If you've heard of Team Foundation Service, which is TFS, or Visual Studio Team Services, VSTS, which is the more one that's come out in recent years, and open source has done a great job in giving developers tools in this space. Mercurial, Subversion, and last but not least, Git, which is what we'll talk about today, is an open source version control system. And that's been really, that evolved in a very open source community fashion. It was driven by the needs of the Linux kernel project. Linus Torvald himself got involved in the design. And so it's evolved because of its speed, its flexibility, and ease of use, I suppose. It's now widely adopted across the developer community. And that's why we're going to give you a brief intro to that today.
Yeah, so we'll talk about the workflow of using version control within the context of Git, and some of these things are similar with other systems, but there are a lot of differences. So in this case, we are focusing on Git.
Yeah.
And the first thing you would always do is create a repository, right? You want somewhere to store your files so that you can work on them, make changes. And then the checking in, as we talked about, is sometimes called committing changes. So you make a commit of a set of changes that you want to store as a complete version. And that's pretty much the core functionality of Git on its own.
Yep, that workflow works in tooling that we'll see, and also, the Git install itself gives you the ability to do a lot of this on a command line. So, but it's very important, the terminology you brought up, Brianna, is kind of the core terminology. There's a thing to store your code, which is a repository, and we do commits, which are these check-ins where we're actually committing our changes back into the storage, and we're rinsing and repeating this process as we write more code, as we fix bugs, and so on. And as we progress in this part of this course, we'll show you what that means when we're doing, working together, collaborating, and sharing code. Because now this version control becomes really important, because, as you said already, I want to see Brianna's changes and my changes, and we need to be able to go backwards and forwards on that.
So we won't demo Git on its own, but we will, as Andrew kind of talk about another tool that works with Git, which allows collaboration with code. And you can also use GitHub on its own individually, but the core of this is collaboration. And you can think of GitHub as kind of a cloud that stores Git repos online.
Yep.
So that people can access them. That's
exactly right. And I think, it's a code hosting platform, but I've used Git to store text as part of my work. It's used by open source projects, companies and individuals, and it's really a great platform to share code and contribute to other people's code. And the contribution piece is really important as you're starting out in your career as a developer. Developers work in teams. It's a team sport, I like to call it. And so GitHub and places like GitHub, there's other vendors do stuff, Bitbucket is another one, but these places online where you can contribute, to other people's code is a wonderful way to learn how to write code, to get well known, to build up your reputation. So I think I'll jump in and maybe start there. Why don't we show you what it looks like to be on this site called GitHub and to create your first code repository or repo. I'm going to use that phrase from here on, and it's easier to say.
Sounds good. Let's take a look.
Okay, so let's go over to my machine and go back to my browser. And I have an account on GitHub. So we'll start there. If I go to github.com/Andrew J. Byrne, here's what I look like publicly inside GitHub. Now, this is the public view. How do I know that? I know it because I'm not signed in, because on the top right it says sign in. And so this is what you would see if you go there now. You would see this. All it's showing you is a picture of me wearing shades, which you can change, thankfully, into anything you want. It's a little bit of profile, some organizations I belong to on GitHub. So I'm in Microsoft, so I do a lot of coding there. But a lot of in the center area here, you see some repositories, repos that I have pinned just to make them more accessible to people if they come to my site here on GitHub. So again, everybody who gets an account on GitHub will have a github.com/username as their landing page. I really love this view. Down, if I scroll down, you see this contributions dashboard. So the geek in me loves to see how much coding I'm doing. And so the darker the green, the more check-ins I've done that day. So let's roll over. July and August was actually very busy for me. I was doing a lot of work on one of my courses and happened to be just merging a lot of code. And so you can see, like on the 17th of July, the 23 contributions. So a lot of cool info along here. If I scroll back up, that's my overview of my presence on GitHub. If I look at the repositories tab, it's a list of all the public repos that I have available for people to consume, and we'll show you how to consume those in a while. And then people who are following me is in the followers tab, and then following is people I'm following, etc.
And I think it's worth emphasizing the community aspect of GitHub and sites like this. Like you mentioned, on both the collaboration front, being able to find something that someone built and you want to contribute to and you don't know the person.
Yeah.
And also to just showcase your work. Employers ask for GitHub profiles sometimes, so it's really good.
Absolutely. I spend a lot of time in one of my courses explaining that, and the fact that, it's a great way to go and learn and contribute. And, when you're ready, you're not always going to be ready to contribute to these online places. You might feel, you're not ready just yet, but when you are, it's great to just get in there, and there's sites that you can go to that will show you what repos are looking for contributions, and you can contribute straight away to someone else's code. But for now, let's go back to the idea of creating your very first repo. And I'll use my account because it's simple to do that, and you'll follow the same steps as soon as you go and get your free account, okay? So under the repositories tab, or back in the overview, so the first thing I forgot to do is I'm not signed in. So as I said, I'm not signed in, I can do nothing. This is the public view, but I did open up earlier on a view of me, I think that's signed in, yes. So just to save some time, I don't want to take out my phone and do authentication and all that stuff. I've just logged in already, and here I am, and my little profile picture is up here in the top right. I have a different view now. If you know what you see here is the repo count has gone to 35. That's because it's showing me I have private repos as well. So when you're in and you're logged in as yourself and you go to your own profile, you get a bit more information about your presence. So let's create a new repo. I hit the new button, and because we're going to show you maybe GitHub and source control in the context of web apps, why don't we just name this repo something like Hello Web App. So here I've typed in a name. It's unique to my organization, to my account, Andrew J. Byrne. So I'm going to create a new repo called Hello Web App. I can put in a description. No need to do that now because of time. I'll keep my repo public. What does that mean? It means as soon as I create this, Brianna could go straight to my account and see this repo, which is probably what we want to do here for the demo. And then you can also make them private. You can initialize the repo with a README. A README is just a text file and very handy. Everybody expects when they walk up to a repo, especially a code repo, that it has a README file, because it's there. They'll seek first some information. They'll go there to see what the developer has said about what's in this repo. So it's useful. This is where you put useful information. So I'll initialize and have GitHub create a README for me. Now I'm going to hit the Create Repo button, and in no time at all, there it is. It's created. So the repo was created, and it's launched me into that page. So I have Andrew J. Byrne, Hello Web App is my repo. Here we are in the default view for the repo. It's because I've only got one file opened, it's shown me by default that file opened, which is readme.md. And the contents of that file is just Hello Web App. So I have one file. You can see I've made one commit, which I'll talk to you about in a second. And I can do lots and lots in this particular view, and we'll do lots and lots in this view right now. So the first thing I want to do, just to bring this back into the idea of writing some HTML, is to upload some pre-canned HTML, to save me some time. So I'll click on the Upload Files button, and I can drag them over, or I can choose them from my browser. So I'll do choose your files, and I'll select hello.html and hello.css. Now it's early in the course. We've gone through some very early stuff for you, and we haven't delved into what HTML is in detail or CSS. Don't worry about that. This is just a demo. I'm uploading files. I could have uploaded hello.txt, and it would have been a text file that I would have uploaded. Here I've put those two files in, and I'm going to commit those changes again into the repo. Commit is me saying basically, yep, I'm ready to store those in my repo. I'll commit those changes using the big green button. And once I do that, it's processing my files, which means it's uploading them into my repo, and the view changes and updates to show me these two files. So now in my list, I have a README, I have hello.html, I have hello style.css, and if I click on one of those files like hello.html, we see, voila, we see a little bit of HTML code. So the next thing I'd like to do is let's take that down onto a machine so that we can run or preview this HTML so you can see what this is actually doing. I think if you're anyway familiar with HTML, you know exactly what this piece of HTML is going to do. So,
and also right now, I'll just, before you make any more changes, to be a good team player, join your repo. So I've navigated to your GitHub page, and now I see your Hello Web App uploaded 34 seconds ago.
Top. Okay, cool.
Yeah. So I'll go ahead and clone that down too, just so that from this point on, I can have access to your repo.
Okay, so we're both going to do that. So from my machine, I have to do the same action whether I'm the owner or not. You know, both of us are going to do this action. So from the main page on the Hello Web App page, we'll click this clone or download button. And there we have this ugly enough, URL or address for this repo. And I'll just copy it. So I can click on copy to clipboard, which it's done, and then I will open up one of my favorite editors, which is Visual Studio Code, and you're following along, Brianna, I presume?
Yes, I am.
Okay, and now we're in here, and I'll just remove some stuff. I'm going to close this one I have open. Have a nice blank start to my Visual Studio Code, and close that message. So here I'm going to, in the welcome page, which you can get to by going to help and then welcome. Okay, there's many ways to get to this page, but this is one way. Go back to the start page or the welcome page in Visual Studio Code and click on Clone Git Repository. And all it looks for is that address. If you remember, I said copy to clipboard. So I will paste that into this particular command bar, and it asks me where do I want to put it, and it doesn't really matter. I'll put it under C code demo and hit return, hit enter. Would you like to open the repository? You see, it's been very helpful. Visual Studio Code has been very helpful to me. I could do all this in the command line, but it's doing it for me all in. That's what code editors are for. So I have this big open repository button. I will click on that, and it launches what I downloaded, or what I cloned. Clone is another word, I suppose, for download, although there is a linkage back to the original. But think of it as just the files are now come down locally, and they're in my Visual Studio Code. And I have my hello HTML, hello stars.cs, and readme.md. There's my HTML file that you did see up on GitHub. I've installed a little extension for Visual Studio Code, which allows me to quickly preview this over in my favorite browser. And we'll show you, or we'll send you a link as to how you can install that extension as well. So if I do Control KD, it launches into my browser. So again, very early days for you understanding HTML and CSS, but take your time, and we'll explain as we go. And again, we're just showing you the version control, which will, you'll get familiar with as you progress. And all we've done here is we've opened the browser, we've given the browser an address to that page that is local, and the browser has requested that page, it's uploaded, or it's consumed that page and rendered it for us using the HTML that was in that page. I could do all kinds of stuff here. If I view the source, for example, you'll see down here it'll show that exact same code that we've seen. But we won't get into that now. That's going a little bit deep. All I wanted to show you was that the page can be previewed now very easily from VS Code, and it's local. So how about you, Brianna? Do you want to show that as well on your side?
Sounds good. Okay, so I have your GitHub profile up, and I see that you've created this repo, Hello Web App, 6 minutes ago. So I will go into that.
So long ago.
I know. So I see your files here, and I'll click the same green button to clone or download. Copy that URL over and switch to Visual Studio Code, which I don't have open yet. I have Visual Studio Code open, and I'm on the welcome screen, so I'll use this clone git repository prompt, paste that URL that I copied from Andrew's profile, and I'll save it in this folder. And it's asking me if I want to open the repository, which I will do. So now I see those same files that Andrew created, and I also have the plugin installed to preview, so I'm just going to use that shortcut to open this in my browser. And we see the exact same.
Great.
web
Yeah.
app.
And so there you go. Like what we have so far, what we've demoed to you today is there's a thing called a repo. There's a place called GitHub. We store these there and other places. That's one of the places we can do it, but that's good for examples. I created some text files, which is a HTML file, which is going to be used in our web apps, and then cloned. So the term clone is when you take that online repo and you bring it locally, and they're interconnected. I'm going to show you that next, but I've basically cloned the repo, and Brianna was able to do the exact same thing, even though pretend we don't know each other. She just found that cool repo online and liked it and started to look at the code, and that's what sharing is all about. There's no blockage. If once the repo is public, anybody can take the code and use it. So here we are, and the next thing I'll probably show you is what happens if I make a change. So I prefer a much more personal touch. So this says hello world, but I'd like it to actually say hello Andrew, because that would be nice. Yeah. So I'm going to go back into my machine, and here I am still in the code. I'm in the hello.html page, and again, we're going to cover all this HTML in detail later on in this course. For now, just focus on the text that you see in front of you, which is hello world, and all you need to know is that little tags that it's between, tell it to display or render at a particular size inside the web browser. So I'll just change that to say hello Andrew. Actually, I'm going to say hello, Brianna.
How nice.
How about that? There you go. And then I can save that on my machine. And when I save it, watch what happens. So I don't know if you saw that, but on the left-hand side of Visual Studio Code, it went from showing me an indication up here in this unsaved files. It says you've one unsaved file. I saved it, and then GitHub, this little source control icon, which is this kind of fork icon here on the left bar. When you click on it, it shows me, hey, you've changed something locally, and it says I've changed the hello.html file. So Visual Studio Code is really working behind the scenes here, and it's detecting changes, and it's doing that because it knows Git. Git is what's running here. And so what I will do is I'll double click on this hello.html file just to show you the change. Let's step back. So I've double clicked the hello.html file inside that GitHub, that changelog, if you like, that source control changelog. And it's actually showing me and highlighting in wonderful colors what I changed. It's saying that I changed that word world to Brianna. So getting a lot of value out of Visual Studio Code integration with Git, and I'm also, the power of Git is showing me the history of this file or the change I'm about to make. So it's all local. I've made the change, I've saved the file, but I haven't committed it to my repo, and I haven't even committed it to my repo locally. So the idea next is that I would make this commit. The commit is the act of committing the change into my storage, into my repo. And you always should produce a message with each commit that you make. So, and what I will say inside this in this little message field, I will say something like, make message more personal. And if I hit the little check mark, that will make this commit. My check mark, my little hand is, you can see it says commit there as a tooltip. I'll hit commit, and it says you'd like to automatically stage the changes, and I'll say yes, and the commit has been made. So that's gone into my repo, Brianna, but guess what? If I look on, I'll just go to my browser, and if I go back to my actual browser itself, I'll just refresh this page, I go to Hello Web App, and I look at my code, I see hello.html is there, but it still says hello world. So I've committed my changes. You have to get your head around some of this kind of way of working. I've committed my changes to Git, to my repo, but it's all just been done locally at this point. The next stage is what we call a push. So I'm going to do a push back up into GitHub. So I'll go back to Visual Studio Code, and there's many ways you can do this. I like to select the 3 dots and choose sync. And all sync does is it would do synchronize in both directions, but we're just doing the push. I can also do a push. Why don't we just do that? So I'll hit push, and it will take whatever changes I've made locally inside my repo, and it will synchronize that up to my repo online on GitHub. So I'll hit push, and you can see it's busy. I got a little clock icon. I got a little progress bar. It's taking its time. Everything goes silent. Let's see what happens. I'll go back to my browser and go into my GitHub repo. I'm still on that page that I was looking at, hello world, but if I refresh it now, I wonder, there you go, hello Brianna is online. So I've made a change locally, I've committed it locally to my repo, and then I've used Visual Studio Code to make some Git commands. Everything behind the scenes is Git, and you can learn about those things at another time, but the Git command is the push command, which will send my changes back to my repo. It has the intelligence to know that this repo that Andrew has locally is actually linked to an origin repo up on GitHub with this particular address. So there's my changes. I wonder, maybe next thing to do is show a pull. So I've done a push, which is pushing the changes up.
Yes. So if I go back to my local repo that has your files in it from your repo, a clone of your repo, nothing, I don't see any changes that you've made because I've pulled this down before you made those changes. Okay. So I can go to that same source control view in Visual Studio Code. And this is something I would do if I'm curious to see what changes have been made or I want to make sure I have the latest version. So I'll use this pull option. And we have that same UI. That was pretty pretty quick. I think
Very
it's done
quick.
now. So let me look at the latest version of these files. Oh, it's already open right here.
Already open.
So I have hello, Brianna.
Let's see what that looks like in the browser.
Okay, so I'll open that preview. And
Oh,
there it
now
is.
that's much more personal.
Yes.
So that's kind of a whole round trip. That's actually what we've done there in that little demo was the full basic GitHub workflow.
Yes.
So created a repo, added some changes, cloned stuff locally, did some work, pushed changes back up to the remote repo, then someone else pulled those changes down, or I could pull them down on another machine, whatever. So it's all this flow, it's all taken care of. If I was to go back, let's just go maybe briefly back to the Hello web app on my machine inside the browser, because one thing you'll see once you're in GitHub now, actually this is not, yeah, I can show you here. If I look at that file, hello.html, it has a history. So there's a history button here. When I click on it, Git is behind the scenes, and all the work to show you the history that we've done is all available here inside GitHub. You can see that my last commit was called Make Message More Personal, and if I click on this ID here, it will show me inside a kind of comparison view. It shows me that the red means I deleted or removed something, and the green means I added. So I've removed that word, and I've replaced it with Brianna. So even in GitHub, the power of Git is now shown to you in a lovely visual UI, a great user experience for that as well. So that's really all I wanted to show today, is just this brief intro to source control and Git and GitHub.
Yeah, and our goal here, there's so much, this is a core workflow that a lot of people can use, and there's opportunities to extend that depending on the scenario, but there's more to learn about Git on its own. There's more to learn about working with GitHub. And Andrew also actually has a writing professional code course on edX, where you cover a lot more of that, right?
I do. I cover the command line, and I go into more depth into what each of these commands mean, and I add some more in terms of, if you've ever heard of a pull request. If you know a developer, they'll probably mention pull requests to you. And so we go into some more detail about how you would do this in a professional scenario where you might have multiple developers on a team. And so we go into that more. It's called Writing Professional Code, and it's on edX, and we'll probably show a link at some point.
Yes, I'll link it in the course resources here. And what we've covered so far is enough for the rest of this course. So what we've covered, you'll be good for the rest of this course so that you can manage your code as you learn more about building web apps. But if you finish this and you're interested, go ahead and check that out. And thank you for being here with us to introduce this topic.
It's been my absolute pleasure.
We hope that you see the power and the need to use source control with your code, and have fun when we get to the next video writing our first HTML code. So I'm sure at this point you're ready to finally get into some code, and that's what we're going to do in this video. We talked about the components of web applications, and now we'll get started with the first language we'll need to build web apps, which is HTML. So let's talk about what HTML is and what it's used for. HTML stands for Hypertext Markup Language. And there are a couple of things we can take away from that acronym. Probably the most important is what type of language HTML is. So being a markup language means that we're not really doing anything new with HTML. We're not creating any sort of action or behavior. We're really labeling content that we have for our web pages and giving it more meaning and describing it. So markup languages are used to mark up or annotate or label things. And with HTML, we use what we call tags to mark up the contents of our page. And the reason that's important is because tools like browsers, search engines, or screen readers and other types of third-party tools need to be able to look at the content of our page and understand what's on it and how to use that content. So headings are important, images are important. Everything on our page is interpreted in a slightly different way, and HTML allows us to describe those different types of content. And in the case of browsers use that information to actually display our web pages properly. So without any sort of styling, we can just use HTML, and our headings might be displayed differently from the regular text of our paragraphs, for example. And just to make sure I explain the full acronym, the other word we haven't talked about is the word hypertext. That might sound familiar from the acronym HTTP, which is the language that web servers use to communicate with clients. That stands for Hypertext Transfer Protocol. Hypertext is an integral part of how we use the World Wide Web. So these documents, the web pages, are hypertext documents. They're HTML documents. And hypertext just refers to a document that contains links directly to other documents. So when you go to a website, you expect to be able to click on a link and access something that's related and be taken directly to that web page without doing anything fancy or complex. So HTML allows us to create hypertext documents. So let's take a look at how we use HTML to build our web pages. If you think about the kind of content that you usually see on a web page, it's some combination of text like headings, paragraphs, different types of lists. You might have images, videos, and other types of media, and the list goes on. So HTML is simply a set of specifications for these elements that we can use on our pages, and each element consists of a set of tags that we use to create it. We do this by wrapping the tags around the content that we are trying to mark up or label. So you would use a start tag before the content, and then an end tag, which usually has a / before it after the content. And all of these tags are surrounded by angle brackets. So for example, here this is a line of HTML code that uses the P tag, which is for the paragraph element. So we start with the P tag. Then we have our contents of our element, which is the actual paragraph text. So in this case, this is my paragraph text. And then once we're done with the content that we actually want to be displayed on the page, we finish with the end tag. So everything in between that start and end tag is the contents of the element, and that's typically what's displayed on the actual web page. Now, it's pretty hard to become familiar with the details of every single HTML element that you could possibly use. Instead, you kind of want to learn the most common and fundamental elements that are the building blocks of web pages, and then use reference documents when you need to learn more in certain scenarios. So here I have linked the W3C reference for HTML, and W3C is the organization that manages this specification. But in the rest of this video and demo, I'll demonstrate the use of some of the most common HTML elements that you'll need to know to start off. And with that being said, the best way to learn programming or to learn a new programming language is to see real code and to get your hands dirty. So I'll jump right into a demo where I'll show you how to start writing HTML code. So I've just opened Visual Studio Code, which is the code editor I'll be using for this course. And I'll go ahead and open a new folder to work with for this demo. So I'll use the open folder option. I'll create a new folder. Let's just call it demo. And then I will select that folder, and Visual Studio Code will open it to make it easier to work with files in that folder. Now from here, I don't have anything in the folder yet. And in this demo, we'll go ahead and create a Hello World program. So for those who don't know, Hello World is the traditional first program that developers write when they're learning a new programming language or learning their first programming language in general. It's really simple. You're just creating a program that outputs the words hello world. And because it's so simple, it's a great program to start with for every language you learn, because believe it or not, it can be, the code for the hello world program can be pretty different between different types of programming languages. So doing this exercise really shows you the essence of a new language so that you can understand the basics and the syntax and things like that. So we're going to start with hello world and HTML. So the first thing I'll do is create an HTML file to write my code in. Visual Studio Code has these helpful icons here in the folder view. So I'll do the new file option, and then I'll type hello.html. and press enter. That will create a new file for me. And now I'll start writing my HTML code. You can see that Visual Studio Code now knows that this is an HTML file. HTML files always need the .html extension. So the next few things I'm going to write are pretty common for starting an HTML file, and I'll explain them a little bit as I go. So first, you always want to start with a doc type declaration. And this just tells your browser that you're working with an HTML file. Next, we have the tags that create the structure of our basic HTML document. So everything that you're going to work with and write is going to be nested inside of an HTML element. So I'll show you what that means in a second. I'm just going to create my start and ending or open and closing tags for the HTML document. And then everything I write is going to be within these two tags. And the first section of your file is called the head. So you're going to create a head element. And this just contains all of the metadata about your HTML document, such as a title, language specifications, links to other resources, and things like that. And for now, we're just going to put a title here. So I'll use a title tag and give this web page a title. I'll call it Hello World. So in this case, Hello World is the actual title, and we're wrapping that with the title tags. And since that's the only thing I'm putting in my head section, I'll go ahead and close my head element. So just to demonstrate, we talked about tags, but we didn't talk about nesting elements or nesting tags. So in this case, the HTML element contains these other elements. It contains right now a head element, which also contains a title element. And we would say that the title is nested inside the head is nested inside the HTML element, and so on. So in this case, the contents of the title element are the text Hello World, but the contents of the head element is the title element. So next, we're going to move on to the body section. And in this case, so far, everything in the head element is just metadata, meaning it's not anything that's displayed on the body of your web page. But the body element is actually where you will write all of the HTML for things that you want to put on your page. So I'll go ahead and create the body with the start and the end tag. And just to demonstrate right now what the title does, if I go ahead and use the plugin that I have installed on my code editor, I'll open this page in the browser and see what we have so far. And you see we don't have anything on the actual body of the page, we just have a title here at the top. So that title is used here in the browser. It's also used in search engines to display the title of your page and things like that. So I'll go back over to Visual Studio Code and let's just put the text Hello World on the web page. So I'll just add that text here. Just a note about Visual Studio Code, you can see that as you type, you have some visual indicators when you need to save your file, this large dot here. So when I use my save shortcut, that goes away. So now that I've saved and I've added this text here, I'll switch back to my browser and see what this looks like and refresh. So now we have the text Hello World on the web page. So that's it for the first Hello World demo, but we'll keep going. I'll switch back over to my code. And right now, I haven't really used any sort of tags around my Hello World text. It's just right there in the body, meaning it's something on our page. But we can get more specific to describe what type of content this is. Let's make it a heading because it's kind of like a greeting that we're going to have on our page. So we'll use an H1 tag. And you can see as I'm typing here that Visual Studio Code gives me some help with all of the tags that I have available. And when I start typing, it narrows down. And the type of heading that we're about to use is an H1, but you can see that there are 6 for us to choose from. And H1s are the largest headings or the most important content that we're labeling. H6 are the smallest or the least important. So we're going to use an H1 because that's our main greeting on the page. And then it looks like I deleted some text. And I'll wrap this around the Hello World text. And now that should be displayed as a heading. If I switch back over, now we see the difference between how the browser interprets just regular text versus an H1 heading. So that's a pretty simple Hello World demo. And it kind of shows you the essence of how you write HTML code and what the basic syntax rules are. Just to recap, you use tags to surround the content and to label things that you have on your page. And what we have here are the most basic, necessary elements that you use to structure a web page. You start with the doc type at the top. Everything else is nested inside of your HTML element. You have a head section and a body section. The head contains metadata. The body contains all of the actual contents of your page. And the next part of this demo, we'll move on and create a web page from scratch with some more elements that are most common to use. So now we've completed the Hello World demo in HTML, where we learned the basic HTML tags that most HTML web pages will need to get started. And now you should know the basic structure of an HTML file and how to get started with writing some basic tags. So now we'll move on and create a web page from scratch that has some more realistic content on it and uses some more complex HTML tags. If you look at my browser, you see this sample web page I have open. And when people are getting started with HTML and learning web development, I recommend finding some realistic content or something that you care about personally and using that to build something that you're invested in as you learn and practice. So for me, my favorite food is the sweet potato. So for this demo, we're going to be creating a web page about sweet potatoes that just has some basic information and fun facts. So the page I have open in the browser right now is the end goal that we're going to be working towards in this demo. Keep in mind this is a styled version, so it does have some CSS applied to it, which is controlling the color and layout. And for this demo, we're just going to focus on getting all of the content that you see here into our HTML file in an organized and structured way. So just to look at what this page contains before we get started, we have some title content at the top just to label the heading of this page, sweet potatoes with an exclamation point. We have a form over here on the side where we'll ask users or visitors to submit their favorite way to use sweet potatoes. And then in the main part of the page, we have some text and an image about sweet potatoes and some fun facts. And then at the bottom, we just have a small footer which contains just like a basic note about who created the web page. So let's switch over to the code editor and get started working on this page from scratch to get the content out into the HTML page. So I have Visual Studio Code open with a new empty folder, and I'll go ahead and get started with the new HTML file for this web page. And I'll just call it demo.html. So I'll kind of go through this part quickly since we've already talked about this, but I'll add the basic metadata tags for the page, including the HTML tag, the head, and the body, along with the title for this page. So I'll title this, I'll just say all about sweet potatoes. And make sure I close this HTML tag. So now I have the basic structure for the page. Let me just open that in the browser to make sure I did everything correctly. So you see here we have the blank web page and the title showing up correctly. So no errors or anything. So I'll go ahead and switch back. So if you think back to the web page we just looked at for the final version that we're working towards, we have some generic sections of content on our page that we could group together thematically. And HTML actually with HTML5, which is the latest version of HTML at this time, has introduced semantic elements. So these are elements that are used to define sections of content on your page. They don't change how the content on the page is displayed. They're not really elements in the sense that they're defining a specific piece of content, but they group certain parts of your content together to show that that content has a certain type of meaning as one. So the some of the semantic elements that we can use include the article element, which is used to define an article of content on your page. You have the header and footer, the aside, which is used as a sidebar, and things like that. So you can see that the names of these elements really are clear to explain what type of content they're labeling. So I like to start when I have a lot of content on my page that can clearly be separated like this. I like to start with those high-level semantic elements and put those on my page first. So if you think back to my page, I did have a header. I had content that is just a big title on the page that won't really change. So I'll use the header element for that. And within that, I had an H1 tag, and I'll title my page, it was just called Sweet Potatoes. And that's it for the header for now. Next, if I were to go from left to right on each level of the page, I have a sidebar on the left-hand side, and that's where we have the form to ask people for input about their favorite ways to use sweet potatoes. The semantic element that's most appropriate for that, since it's a sidebar and it's not the main content on the page, would be the aside element. So I'll use an aside element, and then within that I have headings for the form. I think first is an H2 heading, and I will, what will I label that? I'll label that Share Your Favorites. And below that, I'll use an H3 to make it a subtitle, and I'll give a more detailed description to say, share your favorite ways to use sweet potatoes. Under this heading and subtitle, we have the form is where we will ask people to input their ideas for using sweet potatoes. Just to start with the basics, I'll skip over the form details for now, but as a placeholder, it's helpful to use comments in your code. And in HTML, the way that we write comments is we start with the same angle bracket for tags, and then we start that tag with an exclamation point, just like with the doc type. That kind of tells that we're not writing a real HTML element, and followed by 2 hyphens. So you can see that that changed everything afterwards into a green text, and the code editor kind of helps you highlight your code based on what type of code you're writing. So everything from this point will be considered a comment until I close out the comment. So here I'll just say add form to ask viewers for input. And to close out the comment, I end with 2 hyphens and the closing right side angle bracket. Now this line is a comment, and it won't be interpreted as HTML that should be displayed on the web page. Okay, so that's it for the aside. And next to the aside on the page that we're going for, we have the main content. And for that, we will use the semantic element, which is called an article element. And the article element is intended to be used to group content that could be isolated and on its own, separate from the rest of your site. So if you have any blogs, or if you have some content that stands on its own within your page, then the article is an appropriate semantic element to use. So in this case, I'll use an article for that main content that talks about sweet potatoes. And that content starts with an H2 that says all about sweet potatoes. Followed by a subtitle, so an H3 that says the best vegetable there is. Next, I have a paragraph that just gives some basic information about sweet potatoes. I have that on my clipboard, so I'll just paste that paragraph in and then close out the paragraph tag. So that's the paragraph I have for that section. Under that, I'll add an image. So for now, I'll also skip that and put a placeholder for a comment, just so that we can start with the basic text and then come back to the more complex tags. So I'll say add sweet potato image here. Next, we had two more sections. The first is a section that is titled Top Producers of Sweet Potatoes. And in that section, I listed in order the countries that have the highest production of sweet potatoes. So I'll introduce a new HTML element here. Since we want to list things and we want them to be in order, the tag that we'll use here is called an ordered list. And what this means is that HTML will interpret this list as having the first item in the list being ranked higher than the second, and so on. So I won't be numbering these items manually, as you'll see, but that's what HTML is for in a way. It gives meaning to the content so that it's known by the browser that the second element should be labeled number 2 or letter 2, and so on. So the tag that we use for an ordered list is OL. And actually before that, I'll just give a heading to this section before I actually get into the list. So I'll use an H4 since we're getting into the actual subheadings of the article. And for that heading, I'll say top producers of sweet potatoes. Now I'll use the OL for ordered list. And for ordered lists, the OL tag is the structure that holds the items. But within that, we have to nest additional elements that hold each item separately. So in this case, I want to list 3 items in my list. So I'll use 3 LI tags. LI stands for list item. And the list item is where you actually put the content of each item in the list. So the first country, the top producer of sweet potatoes, is actually China. So I'll write that here. Then I create a separate LI element for the next list item, which is Uganda. And then the third, which will be Nigeria. Once I'm done entering all the elements for my list, then I close out the structure, which is the OL tag that holds all of those items. So these are nested elements. The LIs are nested inside of the OL tag. And then the final section I had in my article was fun facts about sweet potatoes. So I'll use another H4 since that's kind of the same level of subtitle as the previous section. And I'll say fun facts about sweet potatoes. Actually, I'll just say fun facts. And in this case, since my facts don't have any particular order, I just want them to be in a bulleted list. So in this case, I'll use a UL tag, which stands for unordered list, and the browser will display this as a bulleted list. So I'll go UL, and then the same way I add list item elements to that. My first fun fact will be that sweet potatoes are only distantly related to potatoes. Maybe you're also learning about sweet potatoes throughout this lesson, so that's double the value. Okay. The next fun fact will be that the flesh of sweet potatoes can vary in color. Let's see. To include white, red, pink, and purple. And then finally, the final fun fact will be that it is a misconception that orange sweet potatoes are the same as yams. They don't refer to the same thing. So now that I've added those 3 items, that's all I want, I will close out my unordered list element. Make sure I save frequently. So that's it for the content that I have, and then let me make sure I close out the article, because that's all of the content I have for the article element. Now beyond my article element, the last semantic section that I have is the footer of the page. So I'll go ahead and add a footer here, and within that I just had a paragraph element, and I'll just put some basic text. I'll say developed by Brianna, and that'll be it for my footer, so I'll close that out. So I'll save that, and let's go take a look at what this looks like so far. Remember, we're not expecting the layout to be anywhere near what it was in the version I showed you, because that used CSS, but we should have the content there. So let's see. If I refresh the page, we have the content, and we do not see the comments that I put. So that's something to notice too. We don't see the comment for the form. That's going to be right here, and we don't see the comment for the image. That will be right here. Even though in this file we do have the comments here. So remember, comments are just notes to the developer or anyone looking at your actual source code, but they are not interpreted by the browser or whatever program is running your code. So let's go ahead and add in a few more elements to this page and fill in the gaps. One thing I want to do before I forget is add a hyperlink to a recipe when I in this paragraph where I'm talking about the options for cooking sweet potatoes. So I have a recipe that I want to link to for baked sweet potatoes, and I want the text to still say baked, but when the user clicks on the word baked, I want them to be redirected to the recipe online on another website for baked sweet potatoes. So that kind of means that whatever element I use needs to still show the text baked, but it needs to have some additional information for where that URL is pointing to, or the address of that link. And that introduces the need for attributes in HTML. So attributes are additional pieces of information that go in the start tag of your element when you define it in your code. And what attributes are used for is to provide additional information that is not part of what's displayed on your web page, but helps define the content of your element, or how it's displayed, or how it should be interpreted, and things like that. So in this case, we are going to use an A tag, which is an anchor tag. That's what we use for hyperlinks. And within the A tag, since we don't want the hyperlink to be displayed, that's what's part of the attribute. So the A tag has an href attribute that accepts a hyperlink. So I have the hyperlink in my clipboard. I'm just going to paste it here. So you see that so far I've just opened my A tag, put a space. I've added the href attribute, which is used for URLs. And then I'm just going to close that start tag. And now, just as usual with most of our HTML elements, what we put between the start and the end tag is the content that's displayed on the page. So in this case, I'm going to add my end tag, and since the word baked is between the start and the end anchor tag, that's what we're going to see on the page. And then this attribute is just behind the scenes, and the A tag knows how to use that attribute to form a hyperlink. So let me save this and look at that in the browser to see what that looks like. So I'll refresh this page. Now I see that the word baked is displayed as a hyperlink, and when I click it, it opens a different website with a recipe for baked sweet potatoes. So you'll see that attributes allow us to provide this additional information, and certain tags have attributes, just like the A tag expects the href attribute. Certain tags have attributes that they work with, There are certain attributes that are useful for every HTML element. So we'll start to see which elements attributes are useful for as we go along. And actually the next element we need to work with, which is the image tag, so we can fill in this gap here, does use attributes as well. So now I'm ready to add an image to my web page. The image I want to add in this case is an image of sliced sweet potatoes. And I already have that saved into the same folder that I'm working from. You see that the image here is slice.jpg. So the way that we add images in HTML is using the img tag. So I'm going to go ahead and start that. And before I close the opening tag, this element also requires attributes, just like the hyperlink or the anchor element did. In this case, all of the information that we give to the image tag will be in the form of attributes, because we actually don't have any text that shows up on the page for an image. We really just need to specify the path to the image file. That's the number one requirement. And then optionally, we can also give subtitles or the size of the image. So for now, we're just going to give the path to our image, and since it's saved in the exact same folder as this current HTML file, then we can just give the file name. So the attribute that we use to do this is the source attribute, which is src. So I'll do source equals, and then I'll give the name, which is sliced.jpg, and just close that image element. So in this case, this is a self-closing element or tag because we don't need a start and an end tag. We usually need those because we are surrounding content with the tags. But in this case, there's no content to surround. So we just use a start tag and close it there. Okay, so that's it for the image. And it looks like the last thing we're missing is the form at the top. So in this case, the element that we use to create forms is the form element. So that's really easy to remember. And a form is just a collection of input from users that we want to collect in a group and then submit for some sort of processing. So right now with just HTML, we can't really do any processing. So we're just going to have the form there. It's not really going to do anything when the user pushes enter or submit, but we can still create the form in HTML. So we start with the form element, and that's just a structure to hold all of the different input types that we want to use for the form. So let me go ahead and close this just so I can create that skeleton. And then within the form, we can have different types of input. And a lot of these input types use the input element in HTML, which is the input tag. And to differentiate between different types of input, we just use the type attribute here. So we would do type equals. And there are a lot of different, you can see that Visual Studio Code is giving me some options here for autocomplete. So you can have buttons, checkboxes, date. These are all different types of inputs that you could use. And in this case, since I just want to first ask for the user's first name, I'm going to just use basic text. So that's just a small text box input. And for inputs, you also need to give a name, which won't really make sense right now, but once you process the forms later, this is the labels. The name is used as a label for the value that you submit for processing of your form. So I'll just call this first name. I'll use hyphens for now. And the last thing I can do is give a placeholder for the text that will appear inside of this text box before the user types anything. So in this case, I'll just type first name. Input elements are also self-closing because all of the information we needed, we've already provided via attributes. The next thing I want to use is a text area. In this case, that's a larger input box that can accept longer input. So I will just give this a placeholder. Oh, in the case of text area, actually, this is not a self-closing tag, so the placeholder or the text you want inside of the text area actually goes between the start and the end tags. So in this case, I'll say enter your favorite, I'll say describe your favorite use of sweet potatoes. So now I have a text area, and I'll actually go and add some attributes to this as well. The first attribute will describe how tall the text area should be. Not necessarily in terms of height in pixels, but in terms of how many rows of text we expect the user to type. So I'll just put 4 rows in for now. And then the second will be a name for this input as well. So I'll call it description. Now every form needs some kind of submit mechanism. So once the user finishes entering the input that you're asking them for, you want them to be able to signal that they're done and submit the form for processing. So in this case, we'll just add a button. There are 2 different ways to do that, but in this case, we're going to use the input element, the same one we used above. And in this case, instead of type equals text, we'll do type equals submit. So that is a submit button that we'll create. And then we'll just give a value of submit, which is the text that will appear on the button. So now we have a form and we have 2 inputs in addition to 1 submit button for that form. So it looks like we have all the content we need for the page according to the final version that we're aiming for that I showed in the beginning of this video. So I'll save this and head over to the browser to take a look. Refresh the page. And let's see, we have a form here. We have our different sections. We have a huge image. And we have the rest of our text. The one change I'll make before we move on to CSS is to change the size of this image in the HTML. So I'll switch back over. And I can actually add 2 more attributes to the image in addition to the source attribute. So I'll just add a width. I'll make that 300. And actually, if we just do width, this height should change accordingly. So let me switch over. Yeah. So we'll just use a smaller image. I'll put a width of 300. And that makes it easier to look at our page. So this is the result of our page using HTML only. We got all of the content on the page, and in addition to what we can see here in the browser view of the page, we've given our content a lot of meaning semantically. So if I switch back over to the code, we see that there are some things that aren't being conveyed on the browser right now, like the fact that we're using an article, an aside, a header, and a footer. Those things will help in the long run, especially when search engines and accessibility tools access web pages. But that's what we do with HTML. We lay out the content, we structure it, and we provide meaning so that it can be interpreted in the right way. So we'll continue with this in the CSS video, but for now, this is a good use of a lot of HTML tags, and we covered a lot of really common ways to use HTML. Welcome back. So we've covered how to define the content of web pages using HTML, but at this point, those pages are in black and white, and we can't control the look and feel, which is pretty important. So let's take a look at how we can style pages using CSS. So let's talk about what CSS is and what we use it for. So far, we know that HTML is what we use to define the contents and structure of a web page. So we define the actual text and the elements that will be presented on a web page. But as you saw in Module 1, you can't really control much of how the web page is displayed using just HTML. So CSS is responsible for the presentation of these web pages. And that's something that we really want to emphasize, is that the content of a web page is a separate concern from the presentation of the web page and from the behavior of the web page. So we have different languages to control each of these aspects of web development because it's really important to keep these things separate. It makes it easier to develop them, it makes it easier to maintain the different aspects, and so on. So CSS focuses on style and presentation. It stands for cascading style sheets. And the way that we use CSS is we apply it to HTML so that we can access and modify the styles of those elements that we created with HTML. You can actually apply CSS to any type of markup document, which HTML is an example of, but it's most commonly used with HTML. Some of the things that we modify when it comes to style with CSS are the color, the layout, size, font, and so on of the elements that we have on our web pages. And the really good thing about CSS is that because we have that separation of content and presentation, we can swap those components among each other to modify different web pages with the same CSS. So we'll see an example of that on the next slide. So here's an example of what a CSS document might look like. Don't worry about understanding the syntax just yet, but what you can see is that you have some properties that you're calling out, like background color, text align, font size, and things like that. And you're giving those values to modify those styles. So you might remember this web page from the last module with HTML. So this is just a web page that's built only with HTML, and it doesn't have any style applied to it, so it's pretty plain. And if we applied this CSS to this HTML file, it might look something like this. And you see that we didn't change the content, we just added CSS that modifies the properties of the content that we already have on the page. So just to reemphasize this concept of separating content from presentation, let's visit this website called CSS Zen Garden, which does a great job of demonstrating this. So this is the CSS Zen Garden homepage, and if you take a look, it's just a basic web page. It has some content. You see some sections. One section is the participation section. We have a requirements section. And what's cool about this website is that there are different versions of this same page that have the exact same content, the exact same HTML file, and the only difference is what CSS was applied to the web page. So if we look at a different example, a different design, we have, let's look at the robot named Jimmy example. So this is the exact same content of the previous page, but it just has a different set of CSS rules applied to it. And it makes a huge difference what we can do with just CSS without modifying the HTML. You see the same participation section, requirements, and so on. So that's a really good demonstration of the power of CSS and the importance of separating content from presentation. So let's go back to the slides. So let's talk a little bit about the syntax of CSS, how we actually write it to modify these style properties. So a CSS file consists of a set of rules that you define to work with your web page. And a rule is just a combination of a selector and a property. So the selector is how you identify the HTML element that you want to modify. So in this case, this selector is selecting the H1 element. And in this case, that would select every H1 element on the page that the CSS is working with. Then we need to tell the computer what we want to do to the elements that we select. So that's what the property is for. So the property consists of a property that we identify, and then we give a value for that property for how we want to change it. So in this case, we're changing the font family of H1 elements to the value Helvetica, which is an example of a font that we can choose. So that is the basis of what CSS revolves around. To write CSS code, you write a set of rules in which you identify the elements that you want to target using selectors, and then you modify the properties of those elements to change their styles. I'll cover a few of these properties in an upcoming demo, but it's impossible to learn all of them at once. There are a lot of properties that you can use, and you'll likely want to start with the basics and most common ones, and then move on to more properties once you need them for specific uses. Here I've linked the W3C website where there are a list of the properties that are available to you. W3C is the organization that manages the CSS specification. So you can check that list out and take a look at the list of properties. But in the next demo, I'll focus on the most commonly used properties and kind of give you an idea of the categories that these properties fall into so that you can have a better understanding of how to proceed going forward. And once you start to practice, you'll get a better understanding and good experience with some of these properties. So let's go ahead and jump into the demo. So let's get started with a demo of CSS. And we'll start with the same Hello World demo that we did for HTML. Just a reminder, Hello World is the traditional first program that beginners write when they're first learning a new programming language. The purpose of doing such a simple program is to be able to understand the basic syntax and style and where to write the code when you're learning a new language without having to worry about what you're programming. So we're going to start with something really simple. Now, in the case of doing a Hello World program with CSS, CSS can't exist without content written in a markup language, in our case HTML. So we're going to start with this HTML code that just says, "Hello World, what a wonderful day." So I'll show what this looks like in the browser right now. So this is the web page we're working with to start. Just has the basic text, "Hello World, what a wonderful day." And we will go ahead and use CSS to change the color of this to start. So there are a couple of ways or a couple of places to write your CSS, some better than others. So I'll start with the easiest option and then move toward the most desirable option. So to start, you could actually write CSS right within your HTML, and that's called inline CSS. So if I wanted to change the color of this H1 element that says Hello World, I could do so right here in the start tag of the element using the style attribute. So once you use the style attribute, you can just go ahead and write CSS code right within those quotation marks. So in this case, I'll just change the color of that to blue. And if you remember, this is just the property I'm going to change, and that's my CSS. So if I save that and go back over to my browser, refresh the page, now the color of my H1 is blue. So that was an inline style. Let's take a look at how to do this a little bit better using an internal style sheet. So in this case, I can go into my head, which contains metadata about the page. So in this case, since the CSS is not content, we're going to include it in the head section. And I can use a style tag to write my CSS. And all you do is between these two style tags, you can directly write your CSS. So right here, I'm no longer writing HTML. I can directly write my CSS. So I'll go ahead and do a rule that will apply to my entire body of my page, and I will give it a property of color. Let's go with orange. Save that, switch back over to the browser, refresh the page, and I see that the color has applied to the body. However, I still see the color of blue, and let me go back to my code to demonstrate why that is. So the cascading nature of CSS is actually pretty important. Rules are applied, the most specific selector always wins when it comes to applying rules to the same element. So in this case, the body applied to all of the elements on the page, and we applied the color orange to that. But the H1 is more specific than the body. So in this case, the blue color for H1 is going to overrule the orange. And we'll see a little bit more of how this cascading works as we go through this example further. So we've talked about inline styles and using internal style sheets in our HTML files, but it's best to keep content and presentation as separated as possible. So what's most desirable is to use an external style sheet and to save our CSS code in a CSS file. So I'll go ahead and copy this. I'll actually cut this rule out that we created, and I'll remove these style tags. And I'll also go ahead and remove the inline style just so we can start from scratch. Save that. So just to make sure that my page is back to normal, refresh that, and we're back to just a plain HTML page. So from here, to create an external style sheet, which is what we want to do going forward, just create a separate file in the same folder as your HTML file. So I'll call this file style.css. And CSS files always have a .css extension. And here I'll just paste that same rule that we used, and let me fix the formatting of that. So here's just another basic rule. It's the same one that we used, where we're going to color the entire body section, the font color of that section, orange. And with CSS files, you literally just start writing your rules directly into the file. There's no setup or anything like we have with HTML. You just jump right in and define one rule after another. So if I save this and go to my browser, nothing happens. And that's because these two files don't know about each other. And more specifically, the HTML needs to know about the CSS so that it can apply those styles to the web page. So if I go back to my HTML file, I need to link the CSS file to the HTML file. And essentially what that does is pull in those CSS rules and put them right back into this file the way that we did with the internal style sheet. But it's still better to keep them separate until that happens automatically so that it's easier to maintain our code and to read what we're doing with our code. So to link in a CSS file, we use a link tag in HTML, and we need two attributes. The first is the source of where this file is. So if it's in the same folder, you just have to give the file name of your CSS file. And we do this with the href attribute, and then I just give the name of my file. And then the other attribute that we give is the relationship that this file has to the HTML file. So it's the rel attribute, and then we just tell it it's a style sheet that we're pulling in. And this is a self-closing tag since there's no content that we're actually displaying. So now if I go back to my browser, I should see these changes reflected. And I do. So in this case, you want to always use, let me go back to the code. In this case, you always want to use an external style sheet when you can, because it's just easier to maintain your code and to reuse it in other places. And what you need to remember when doing this is just to link your CSS file from your HTML using a link tag, and then write your rules directly in your CSS file. So now that we've completed the Hello World exercise with CSS enhancing our HTML page, we'll move on from that to a more advanced demo where we'll cover some more CSS properties and go into more detail with how to use CSS to effectively design and lay out web pages. So the page I have open here is it's the same thing we were working on in the HTML module, and this is what we're going to work towards as we style the HTML page we left off with in that module. So it's not designed according to any design standards or anything like that by any means. This is just designed more for a teaching tool to demonstrate a lot of the properties and things that you'll come across as you learn. So we want to play with color, sizing, layout, and things like that. And this is a basic page that will allow you to do that. So as you can see, we have a background color, and some of the different sections of the page have different background colors. We have different font colors. We have things that are positioned in different parts of the page, different sizes. So we'll kind of walk through and demonstrate how to achieve this final look, starting from the basic HTML code with no CSS and turning it into something like this. So here's the HTML file that is responsible for setting up the content of the page that we are working to recreate. You can see it just has some semantic elements such as the article, aside, header, and footer, and some text content, an image, and a form for users to input some information about their favorite ways to use sweet potatoes. So this is what we'll be starting with. So let's take a look at what this looks like in the browser. So here you see we have just plain text. This is just what the HTML produces with no CSS applied to it. And we're going to start with this and add CSS gradually to end up with the end result we desire. And we'll start with applying that CSS by focusing on organizing the content first. We see in our HTML that we have a lot of these semantic elements that we mentioned, and we'll start with those. But first, let's start by linking our CSS file, a new external style sheet. So I'll use this button to create a new style sheet, and I'll call it style.css. And then I'll go ahead and link that before I forget, just so that we can get that out of the way. So I'll link it using the link tag in my HTML file. So now going back to the style.css file, we'll go ahead and get started with our first rule. And in this case, we're going to go ahead and start with color before we start moving things around and laying things out, just because it's easier to see where we're putting things if we have them colored differently from one another. So the first thing we'll start with is giving the body a background color, and from the page we looked at, we saw that the background color that I had on the body is orange. But before we do that, actually, let's go back into the HTML because I want to add one more element that we haven't really talked about. I'm going to further group the content of the page using a div tag, and what that does, it's similar to the semantic tags like header and article, but it has no semantic meaning, and it just allows you to group things together for stylistic and manipulation purposes. And in this case, we want to be able to apply certain styles to all of the content without using the body tag, because we want the body to be a little bit different from the rest of that content. So I'm going to go ahead and create a div tag here, and I will give it an ID. We haven't really talked much about IDs, but this just allows us to reference it later. And I'll give this an ID of container, since that's what I'm going to use it as, a container for certain pieces of content. And then I'll go ahead and indent the rest of the content within that and add a closing div tag. So that won't have a difference visually, but it will help in upcoming steps. So now we can go ahead and go back to the CSS and continue where we left off. So now I will go ahead and add my first rule to the CSS, and that'll be on the body section. So I'll use a body selector, and I'll go ahead and give the body a background color of orange for the theme of my sweet potato website. So if I save that, we can go ahead and have a look to make sure everything is linked up properly and that it displays correctly in the browser. I'll just save my file. And then I'll head over to the browser, refresh the page, and I see the background color of orange is applied to the body of the page. So now I can add my next style or my next rule. And in this case, I'm going to apply it to the div that I just created. And the way I'm going to access that is using its ID. So to access something or select something using ID in CSS, we use the hashtag or the number symbol followed by the ID that you want to select. So in this case, I gave my container an ID, my div an ID of container. So I'm doing hashtag container, and then I just do my rule as usual with the property. In this case, I have a background color of white for my container. So let's take a look at that in the browser. And we refresh the page and see the background color of white, which is different from the background color of orange on the main part of the body. So now we can continue on with adding color to the rest of the parts of our page. So after the container, if we're going left to right at each level, we could look at the, what's next? The header of our page. So the container contains the header, footer, and all that main content. So if we start with the header, the background color that we're using for that section is a light gray. So I'll go ahead and identify the header, and since that's just an HTML element, this will select any headers on the page, even if there are more than one. In this case, there's only one on our HTML page. And in this case, for the background color, since I said specifically light gray, this is what the regular keyword gray looks like, and I don't want that, so I'm going to specify color in a different format this time using the hexadecimal format. And this allows you to be more specific with particular colors that you want, as opposed to the limited options from the keywords. So in this case, I'm using a color that corresponds to the code EEE, EEE, and you can see that's a really light gray. You can find colors and specify them using hexadecimal. There are a lot of tools online that help you do this, and they have the color picker wheel and then provide you with the hexadecimal code with that hashtag in front that you could just use in CSS. So that's my background color. Then I'll use a regular color keyword. So this is a property that refers to the font color of a section, and I'll give this a color of brown. And then I will use a property called border. So this allows you to add a border around elements. This does add to the size of an element, which we won't focus on too much for the purposes of this video, but I'll add a border, and then I can specify a few parts of the border in one statement. So I can start with the size. I'll do a, let's see, 4-pixel border. I'll make it brown to match the text color, and then I'll make it a dashed border, but that could be solid or dotted as well. So I'll save this, and let's look at what these changes look like in the browser. Refresh, and we see that these colors have been applied to our header section. And notice that the inheritance is at play here, since the header is part of the body, and we've specified a background color of orange for the body, but because the header has a more specific or a lower level selection, then that color of the background color of gray applies over the background color of orange. The next section we want to style with color is the footer, and we'll give this also a background color of that light gray. And then I'll give it a font color of the regular gray, which is a little bit darker, just for that muted look for the text in the footer. And finally, I just want to style the headings in the page. So I'll give hchoose a heading color of orange to match the theme of the page, since those are the biggest headings other than the title. And then I will give h3s and h4s a brown color. Notice that since I'm giving both h3 and h4 the same exact rules, I will just list them both in the same selector separated by a comma. So whenever you list two selectors separated by a comma, then the same rule is applying to each of those selectors independently. And we'll see other examples of combining selectors as we go along. So this should be color is brown, and that should be it for color. So let's take one final look at the page. refresh. And it looks like we have all of the colors we need for the final version. The next thing we can focus on now that we've gotten color out of the way is giving our sections and components the proper sizes and orienting them in the right position on the page. So let's switch back over to the code and get started with that. Actually, before we do that, let's take a look at what's kind of out of order right now. So we want this share your favorite section to be the sidebar on the left, and then we want the all about sweet potatoes, actually everything from here on out to the bottom, to be part of the main article. And then this gray part would be a footer that stretches across both of these, the sidebar and the main article. And we're going to start just by sizing everything correctly, and then we'll take a look at how we can push things to one side or another, and then put space between things. So let's go ahead and switch back over. So starting from the top again, the first thing we'll start with is giving the container a width. And that container, as a reminder, holds everything from the header down to the footer. And we just want to give a width so that within the body, we want that white section that's inside the orange section to have a specific width. And we'll give it 1000 pixels. If we take a look at what difference this makes, I'll go ahead and switch over to the browser. We see that it has a width now, but it still doesn't look very nice. And what I want to do is center this whole white section, the whole container element, in the middle of the page. The way we center elements in CSS that are block elements like this one, which we won't go into too much detail about, but since this element is on its own level, it's not something that's on the same line as something else, we can center it by giving it margins that automatically align. So the margin property is a spacing property that allows us to define the space between one element and another, and we'll give there are a few different ways to specify the margin. One of them is a shorthand that allows you to give 4 values that are assigned in order. So the first value is the top, right, bottom, and then left. So you can imagine you always start at the top with these things and then you go clockwise. So if you only give 2 values, you're only giving top and bottom and then right and left. And that's how we're going to do it right now. So we're going to give values of 0 and auto. So what this means is take away margins from the top and bottom, and this is for our container, so that we don't have any extra space above or below the container that we're creating. And then for auto, that's for the left and right margins, and we want that to automatically adjust the left and right so that this box is centered on the page horizontally. So if I save that and look in the browser, now this box is aligned to be centered horizontally on the page. Next, we're going to go down to the aside. We haven't created a rule for that yet, but let's do it under the header. And we're going to give the aside a width. And this is the sidebar that has the form in it. And we'll give that a width of 250 pixels. And let's look at what this looks like first in the browser. So that's what it looks like, and we want to go ahead and just float this to the left just to make sure that our sidebar is always on the left hand side and the article is always on the right. So floating, as we see here from the handy tooltip or help box in Visual Studio Code, allows you to set or position an element to a certain part of the page. So we have the option to float something left or to float it right. So in this case, I'm going to float that left. And then for the article, I'm going to go ahead and give that a width of 700 pixels and float it to the right. So if I look at this in the browser, now we have the sidebar to the left and the article to the right, but stuff looks a little off right now, and that's because it's hard to know why, but if you notice, the footer is coming above before we finish the content of the article. So we want to push that footer down, and that will help stretch out the rest of this container so that we fit everything inside of it. So I'm going to go back, and within this footer section, I'm going to add a property called clear. And what this means is if anything else is floating, I don't want to, push my element down below those floating elements. So we're going to say clear both, which means clear anything that's floating to the left or floating to the right. Now let's go back and look at what that does. Refresh, and we see that that kind of pushed that footer down so that the sidebar can float to the left and the article can float to the right. The last thing I'm going to do is make sure that the elements of the form are each on their own line. Right now the submit button is kind of next to the text box, so I'm just going to make sure all of those are block level elements so that they take up their own line. So I'm going to create a new rule for the input box and the text area. So going using those commas again, and I'm applying the same rule to both of these elements. And I'm going to make those block elements. I do that using the display property so that they display as block level elements. And that's it for that. So if I go back, now that button is on its own line because each of these boxes is taking up a full line on its own within the containing box that it's in. So that's important to note too. It's taking up the full space of its parent box. So in this case, these are inside of a form, which are inside of that aside sidebar, and we gave that aside a specific width so that this won't go beyond that. Now that's it for sizing things. I think everything has the proper size. So now we can do the final touches in terms of moving things around at a smaller level. The first thing I'm noticing right now is that all of this content in our aside is really close to the edge, the left edge of the container. So we're going to give it some padding. And what padding does, padding is pretty much, you can think of it as the opposite of margins a little bit. Margins are like extending your arms and pushing someone away from you to create that space around your bubble. And padding is giving yourself more space inside your own bubble. So if we give any of these elements padding, it'll push the content away from the border and push it away from this edge of the container. So I'm going to go ahead and do that for the aside. So I already have a rule here for the aside. I'm going to add padding left. So padding is just like margin. You can apply it on different sides using those shorthands, or you can be really specific and only do one side. And I'll give it a padding of, let's see what 10 pixels looks like. So that looks pretty good. Now we have that more space to the left here. The next thing I want to do is center the heading up here in the header. Let's center it horizontally first, and we can do that using the text align property. So here I will go and do text align center, and let's take a look. That looks good. And then the next thing I'll do is, yeah, that sweet potatoes, that title looks good. And then since we're looking at the header, also looking at the footer, I kind of want to push this a little bit over as well and give it a padding left. So I will give it a padding left of 5. I'll do 10 pixels. So I'll say padding left 10 pixels. There we go. Now I'm just going to move some things around at a lower level. For one, I want to remove some of the space between H2 and H3 headings. So I'm going to give each of the H1 through H3 headings a margin bottom of only 5 pixels. And let's see what that does. So since I want to group all 3 of these, I'll just do a new set, H2, H3, and I'll give it margin bottom 5 pixels. Oops, what happened? Then I'll just do for the H3s a margin top of 5 pixels as well. So what that did is reduce the space between those 2 elements. And I think that's a little bit better. Over here, I want to give the form a little bit of a margin top to push it down a little bit. So let's do that. I'll do 10 pixels just to give it some space. And I also just want to put some space between each of these form elements, so I'll give 5 pixels margin top and bottom between them. So that's back to this rule set, and I will do margin, I'll do 5 pixels, and then 0 for the horizontal left and right margins. So that gave it a little bit more space, and I might actually change those to 10 pixels. Let's see what that looks like. Okay, so let's just leave it like that. I also want to space these list items out a little bit, so I'll give each of those a margin top of 20 pixels. Let's see what that looks like. That's fine. Like I mentioned before, we're not really following any strict design principles or really going after a certain kind of design here. We just really want to practice using a lot of these rules and properties. The last thing I want to do is, if you notice now, we've made some changes. This main title or heading of the page is no longer centered vertically. So one way we can fix that is by giving the heading text a line height that is bigger, and once we give it a specific line height, it will automatically center vertically to fulfill that height. So I'll switch back over, and I think I have a section. Yes, I have the header, so I will give that a line height. And a way to specify line height and fonts and font sizes and things like that, there are a couple ways. You can do percentages, you can do pixels, and what I'll do here is the EM unit, and 1 EM is typically equivalent to 16 point font on a default browser setting. So In this case, I'll set this to 5 EM, and that should center it. And it doesn't look completely centered, so I'm going to make sure I take off the margins just so we don't have anything else interfering, and we don't really want specific margins anyway. And actually we need to, in this case, we'll apply the margin 0 to the H1 inside of the header. So to do that, we just use a space instead of a comma between these two selectors. And in that case, we are only applying the following rule to any element that is an H1 that is a descendant of a header. So that means an H1 that's essentially nested somewhere inside of a header element. And for us, that is the title of our page that's inside of our header. Give that a margin 0. Save. And now we see that that centered our text vertically. So that is pretty much what we're going to cover for this demo. CSS is a lot more involved to learn than HTML is. HTML, there's a very limited set of tags that you can use, and it's all about your content and really labeling it. But with CSS, there's so much you could do with different properties and using them in different combinations to create different styles and looks for your page. So it's pretty hard to cover anywhere near everything you could learn with CSS. But the goal here was just to give you an example of how you can combine these properties to create different looks on your page and when and where to use certain types of properties. I hope that demo gave you a good idea of what CSS is used for and how to get started with writing CSS code to work with your HTML web pages. Just as a summary, CSS stands for Cascading Style Sheets, and we use it to control the presentation of web content. And it's really important to remember that HTML is meant to be used for content only, and CSS is meant to be used only for presentation, and that separating those two concerns makes it easier to author our code and to maintain, and it makes it easy to write CSS code that can control several different web pages at once and be reapplied to new web pages. The basic premise of CSS is that you are creating rules in which you apply properties to specific HTML elements, and the goal there is to modify the style of your web page. Those properties fall into high-level categories to cover color, font, size, and position. And with those sets of properties, we can effectively style web pages and transform them in so many different ways. So the possibilities are really endless when it comes to using CSS to style web pages. And although you've only gotten the basics here in this demo, there is a lot more to learn. There's a lot you need practice when it comes to getting experience with CSS and with any programming language in general. If you want to learn more, I do have an edX course that covers CSS along with HTML and other topics. It's called Designing a Technical Solution. It's available on edX.org, and the link is right here. So regardless of whether or not you take that class, I encourage you to practice on your own, build some web pages, style them in different ways, and really get your hands dirty with CSS. I'll see you in the next module where we'll talk about JavaScript. Welcome back. So now that we've covered how to build and style web pages, in this module we'll take a look at how to make those web pages interactive. We'll explore a language called JavaScript and learn about its role in web development, and then we'll take a brief look at the basics of writing JavaScript code before we jump into how to use JavaScript on web pages to create interactive experiences for users. So let's talk about what JavaScript is and what this language is used for. JavaScript is known as the programming language of the web, and it's really popular right now because of this, since web development is such a big area of software development right now. Because of this, you've also most likely been a user of a website that uses JavaScript. If you look at this table here, this is the technologies and languages that the most popular websites right now are built with. And you see that every single one of these uses JavaScript on the front end or the client side. And some of them even use JavaScript on the back end, which we'll talk more about later. So JavaScript's purpose is to make web pages interactive and dynamic. So we need that because with HTML we can create content, with CSS we can style it, but once we do that with HTML and CSS, our web pages will look the same all of the time, no matter what. So one web page will look the same until you go to a different page and reload it. And JavaScript allows us to change how the web page looks or behaves once the user is already on that page. So maybe there's a button and they click it and they need to see something happen on that page without having to reload another page. JavaScript was released in 1995 and it was originally called LiveScript. Just FYI, JavaScript has no relation at all to the language Java. That's something that confuses a lot of people in the beginning, but they're unrelated completely. And as we mentioned, JavaScript is also used for server-side programming, which is why you see JavaScript in some of these rows for back-end development here. So as I mentioned, the overall use of JavaScript is to manipulate web content dynamically and to avoid having to reload pages every time we want to change something on that page. So the way that JavaScript does this overall is by reacting to things that are happening on the page, reacting to the user clicking a button, reacting to a certain amount of time passing, reacting to a scroll or a hover on the page. All of these are called events that can happen on the page, and JavaScript reacts to those events. You write JavaScript code that listens for these things and then does something as a result. And the things that you can do as a result of these events all revolve around changing the HTML content on your page or even adding and removing content from your page. And we'll talk more about those types of things that you can do with JavaScript, but overall this is the premise of how you use JavaScript for client-side web development. And we'll also be using JavaScript for the back-end server-side development, and we'll talk more about that in later modules. So let's take a look at how you write JavaScript code and the basic syntax. So JavaScript's different from HTML and CSS. This is a true programming language because we're actually programming behavior and action. So HTML and CSS are on the markup side of languages. So this might be a little different if those are the only two languages you've seen so far. So in general, JavaScript code is made up of lines of statements. And each of these statements is really an instruction that you're giving to the computer to do something or execute something. So each instruction is referred to as a statement. So if you see here, this is an example of a few statements in JavaScript, and each of these ends with a semicolon, as you notice. Think of that as a period that you end a sentence with. And these are executed in order. So first JavaScript will execute this line and then the one after it. And the way that we write JavaScript code, if you notice here, there are certain words that are different colors. So the JavaScript language consists of certain keywords that we can use that JavaScript understands and knows what to do with those words. And then we have certain identifiers that we give to things as we're writing code. So that might not make a lot of sense right now, but in general, there are certain words we use, and then we create our own labels for things specific to the program that we're creating. So now let's take a look at a demo because a lot of these things will make better sense when you see real code. So we'll jump right in and look at a real demo. So let's get started with this demo of how to use JavaScript for client-side web development. Here I have a basic web page built with HTML and CSS that simply displays a greeting to users and also asks for the input of a name. So just a simple text box and a submit button. And if I type something into this right now and submit, nothing happens because we haven't written any JavaScript code to handle this. But right now this is what we're starting with, and then I'll let you see what this HTML and CSS looks like right now. Here's the HTML file. It's basic headings that we have, as well as the input box and the submit button. And I've given the input box and the button IDs so that we can use those in the JavaScript. So to get started, first I'm going to show a few different ways or places where you can write your JavaScript code. Just like with CSS, you can write your code right in your HTML file in line, or you can write in an external file. And just like with CSS, writing your JavaScript in an external JavaScript file is the recommended way, but I'll show a few ways to do it just for demonstration purposes. So first, I could use a script tag right in my file here and write my JavaScript code directly in this. So if I say alert and I put hello world, what I'm writing between these two script tags is pure JavaScript code right in my HTML file. So this is a line of JavaScript. And now if I save this and open this file in my browser, we see, and then I'll refresh. Now I see this script is running and it's popping up an alert that says hello world. And that was because of that line of JavaScript code I wrote. Now, as I mentioned, that's not the best way because a lot of times your scripts will be much longer than this and you don't want to clutter your HTML file. And if you remember, you want to separate presentation from content and behavior. So in this case, you want to keep your JavaScript file separate to control the behavior of your web page. So I'm going to take this out. And what we're going to do is write code in a separate file. So I'll create a new JavaScript file here. I'll call it hello.js, and that's the extension for JavaScript files. And just to start, I'll use that same alert just to demonstrate that we're doing the same thing, just in a different file. Now the difference here is now these two files don't know about each other. Just like with CSS, we need to link them together. So I just need to include a script tag in my HTML file and give it the source attribute to point to the file. So the name of that file is hello.js. And in this case, you do need a start and an end tag for the script. And all of the code you write in your external JavaScript file will automatically be inserted into your HTML file within this script tag, but it's still better to write that code separately to maintain it separately. So now if I save this and open this in the browser, we see the same behavior, but now we're using an external JavaScript file. So I'm going to keep working in this file and I'm going to get rid of that alert because I don't want to see that every time. And what I want to do in this case is once the user enters their name into that text box and pushes enter or submit, I want to change the hello world greeting to say their name instead. So to say hello to that person's name. So to start, I'm just going to put some comments in my code. You can write comments in JavaScript using a double / or a / asterisk like this. So this is a comment. This is a way of writing it in addition to the double /. So here I'm just going to write what my goal is for this short program. I want to, when the user presses submit, change the greeting to include their name. Now the first thing I need to do is get access to the button and set up an event handler. So as I mentioned before, JavaScript revolves around responding or reacting to events. And in this case, the event we want to respond to is the user clicking the button. We don't want to change the greeting or anything until they've actually pressed that submit button. So we're going to listen for that event and then create a handler that will do something in response to that event. Now, once I get access to that button and set up the handler, actually that pretty much encompasses everything we're doing. So to start, JavaScript revolves around modifying HTML elements. So there's not much you will be able to do in this context without HTML. And in this case, since we're listening for something to happen to the button, we need to create some sort of reference to that button. So in my HTML file, I have an ID on the button, and that's the easiest way to reference HTML elements from your JavaScript code. So this ID I've given is submit, so I'm going to use that ID to reference in my JavaScript. And I'm going to create a variable to hold that reference. Variables are just containers for data in your program. So I'm going to call my variable button, just straight and simple. And the way that we reference things by ID in JavaScript is using the document.get element by ID. And you see that there are a few other options for referencing things, and we won't cover those in this video. But we're going to use the get element by ID, and then in parentheses you pass the ID that you wish to reference. So mine was submit. So now I have a variable that references that button element, and next I need to set up a handler to listen for that click event. So now I can just say button.onClick, and I create a function that will be run once the button is clicked. In this case, I'm going to separate my function into a separate statement. So I'm just going, let's say I'll call it change greeting. And this isn't created yet, but now I'm going to create this function called change greeting. And here what I want to do, first I need to reference the greeting that I want to change. Just like I wanted to reference the button to do something with it, since I want to work with the greeting element, I need to reference that header. So here, I didn't give an ID to this, so I will demonstrate another way of referencing by element type. So this is an H1, and it's the first H1 on the page. This isn't the most reliable way, but just to demonstrate, I'm going to reference it using the type of element this is. So here I'm going to say var heading, I'll call it greeting. And in this case, I'll do document.get elements by tag name, and I'll give it the tag name, which is H1. This will return an array, since there can be more than one element with the same type on a page. There can be more than one H1 on the same page. So I'm going to use the array reference to get the first element in that array, since I want the first H1 on my page. Next, I want to get the actual name that the person entered into the text box. So I need to reference that text box. And I'll do document.getElement by ID again. And let me check what that ID was. I gave that an ID of name. So put that here. And in this case, getting the input element with the ID name just gets me that actual text box. But what I want to do is get the value that the user typed. So I'm going to do .value here. And that method will return that property will return the value of that text box. So I have access to the value that the user inputted, and I have a reference to the greeting element that I want to change. So now all I need to do is change that greeting to include that name. So to modify the contents of an HTML element from your JavaScript, there is a property called inner HTML, and that's what we'll use to change the text of that heading. So now I'll just say greeting.innerHTML, and I'll set that equal to a new line of text, which will read hello, and then I'll append the name to that. So in this case, input is a variable that's storing that value that we got from the text box, and it's just going to be used here and appended to the text hello. And that's it. So just to look over this again, we got access to that button, and once it's clicked, we are instructing our program to run the function called change greeting. And in that function, we are getting access to the greeting heading, getting access to the text box, and pulling that value from the text box that the user inputted, and then changing the text of our greeting to read the user's name. So let's see if this works. Refresh the page. I'll type my name, type Bree, and now I see hello Bree. So it works. So that's just a simple demonstration of how you can use JavaScript on your web page. Everything pretty much revolves around setting up event handlers and modifying some aspect of your HTML elements on your page. That's what JavaScript is most useful for, and that's the premise of it. If you do not have a background in basic programming, some of this might not have made perfect sense, so be sure to first learn the basics of programming in JavaScript, and then you can use those skills and concepts to use JavaScript in this context for client-side web development. Just to summarize again, JavaScript is used to control the behavior of web pages. And we know that HTML is used for content, CSS is used for presentation, and JavaScript's role for controlling the behavior of web pages is necessary and very useful. As I mentioned just now, it's useful to understand the basics of programming in JavaScript, which will be the same as programming in other languages, before you get into working with the HTML elements referred to as the DOM. So if you get a basic foundation in variables, conditionals, loops, functions, and arrays, that will give you a good starting point to be able to understand the code you will need to write to work with your HTML elements on your web page in the way that I just demonstrated. And once you get to that point, you can learn the events that are common, as well as the DOM methods that allow you to modify your HTML. From there, a useful thing to learn is jQuery, which is a JavaScript library that makes writing JavaScript code a little bit simpler and allows you to do some more advanced things in an easier way. One thing that jQuery is particularly useful for is sending AJAX requests from client to server. So what that allows you to do is pull data from a database or a server for your app and display that on your web page using JavaScript. So that's something that was not covered here, but will be useful for full stack development using JavaScript. And as I mentioned before, to learn more, you can take the edX course I have on edX.org, which is called Building Interactive Prototypes Using JavaScript. The link is right here. So far, all of the technical concepts we've covered focused on the experiences of our users in the browser side or client side of web apps. But a web app isn't fully functional without a way to store and retrieve dynamic data so that the app can carry out logic. In this module, we'll explore these back-end web development concepts and learn how to set up a basic server to handle the logic for a web app. So earlier modules of this course focused on client-side web development. We talked about HTML, which is used to define content, CSS, which is used to style and present that content, and then JavaScript, which is used on the client side to add behavior to web pages by modifying and reacting to events with that content. And these three languages are used to build our client side, which is the interfaces that our users view and interact with on our web pages. So what's left after that? If we're actually going after creating a functional web app, an application that does something and handles data, then we need a server, and we need to learn more about server-side web development. So let's take a look at how the client and server side of a web app work together. So the client, as we know, is the HTML, CSS, and JavaScript code that is running on your user's machine, most likely a web browser, whether that's on their laptop, their mobile device, any device with a web browser, that is the client. And that's running your HTML, CSS, and JavaScript. And at some point, your app will need to display some sort of data that is dynamic, that's not the same for every user, that's not the same for every scenario. And in that case, it needs to communicate with a server who can handle that dynamic data using a database and handle the complex logic that your app might need to perform to calculate things or to present that data in the right way or to identify the right set of data that should be used. Your server can handle these requests, communicate with the database, and handle any app logic before responding with that data back to the client. So the communication between clients and servers relies on requests from client to server and then responses from server to client. To go into a little bit more detail about how clients and servers communicate, they communicate with each other using a language called Hypertext Transfer Protocol, or HTTP. HTTP contains a set of requests that clients can use to communicate with servers to ask for data. These include the get, put, post, and delete requests. So those are the types of requests that clients will send to servers, and then servers will respond to clients with that data or a status update or a resource like an HTML page or a CSS file, or even an image. So HTTP is the protocol or the language that is used between clients and servers. And we'll see, we'll need to remember these get, put, post, and delete options when we're writing the code for our servers, because the server will need to handle each of these types of requests. So the role of your web server is to really just listen for these requests, and then set up handlers to react in certain ways based on the type of request that's coming in. At some point, your app will probably need to carry out some sort of logic in order to handle the request, communicate with a database to get certain data, and then respond to the client with the data or resources that were requested. So this is fundamentally what a server is responsible for a web app, and it's really the brains that handles all the functionality of your web app. And that's what we're going to be programming when we talk about server-side web development. Since these functionalities are pretty common, most web servers need to do the same thing. There are frameworks that make it easier to do the common tasks so that you can focus on what is unique about what your app needs to get done. So a framework that we're going to be using in this case is called Node.js. And it's really useful that this is a framework that allows you to write JavaScript code to run on your web server. So JavaScript wasn't always used for server-side development. Its primary purpose is for client-side development to make web pages interactive, but now we can use it for both client-side and server-side. So as you'll see, Node provides different modules that handle the common server functionality that we need to program into our app, which makes it really easy to quickly build server-side components for a web app. A framework that we're going to be using on top of Node.js is called Express, and that specifically, we'll use that to handle routing and setting up an API to handle the various types of requests that we expect from our clients. And here is a link to download Node, because that's where you should get started when you're with this process. So in the rest of this video, I'll show you a demo of how to get started with Node and set up a basic app that handles requests from a client. So in this demo, we'll get started with adding a backend or server-side functionality to a web app, a simple web app. And this is the state of the web app right now. It's a web page with HTML, CSS, and JavaScript on the client side. And I actually worked with this example in the HTML and CSS modules of this course. And I've added just a few more things to make this appropriate for this backend functionality demo. So the functionality that I'll be programming in terms of the data I'll be storing relies on comments from users. So I have this form where users can type their name and a comment and submit it. And then what I'll do is have each of those comments and names stored in a database and displayed on the page. So every time someone adds a new comment, that will be stored in the database so that every other user of this page will also see the comment here. So right now, since I have only built this with HTML, CSS, and JavaScript, I just hard-coded some sample data in just so I can see the look I'm going for, just as a placeholder. So that's why this is repeated text here. But I recommend doing that so that you know what you're going for before you start writing your server-side code. So here is the code for the page that we were just looking at. I just have some basic HTML using semantic tags and basic tags. And then here I have a section with the comments that I'll take this out once I'm done with the server-side code. But for now, I just have placeholder text. And actually, I'll go ahead and comment that out right now, since we already looked at what we want this page to look like. So I'll just use an HTML comment from here all the way to the bottom of this section. So now everything in green is commented out and won't be displayed on my page. So I'm going to start just by setting up a basic server for my Node app. So right now this isn't really an app, it's more of an interactive web page. So the first thing I need to do is add a file for my server code. And I'll just call this server.js, which is a common name for this file. I'll also organize my files into client and server side. So I'll put all of my client side files into a folder called public. Oh, it looks like I've already done that actually. So I need to take this server file out of my public folder. There we go. So in this file, I'll start with setting up my Node and Express app. So the first thing I'll do is import the modules that I need from Node for my app. And the only module I'll use right now to get started is the Express module, since that's the framework that I'm using with Node. The way we do that is just by creating a variable to hold the object for Express. And we use the require function to include that. And then now I create a variable for the app that uses Express to initialize an app. And in this case, the first function of a server is to listen for requests. So we just need to have our server up and running and listening. So the first thing I'll do is use the app.listen function. First, I need to give it a port number, and you see that we have this help here from our code editor. So if you ever forget exactly what a function needs, that's useful. So first I need to give a port number. I'll use port 3000. And next I give a function that is just what will happen once we start listening. So in this case, I just want to log a message to my server console, which I can look at just so I can make sure everything's running and always see, debug and diagnose things. So I'll just say server is running on port 3000 just to verify. Put a semicolon here. So now I have created an app and I have it listening on port 3000. Now I haven't initialized this project or this app as a Node app. So for the rest of this, you're going to be working in the command line a lot when you're working with Node. So that's something you should brush up on if you're not familiar with command line already. So I'm going to open my command prompt. So I have my command prompt open, and now I'm going to navigate to the folder where I'm working, which is on my desktop. And this is called sample. And now I'm in the folder where I have all of my files. If you see, my public folder and my server file live in a folder called sample. And now I'm going to, I have Node installed, so when I'm using these commands in my command prompt, it's using the Node engine. So I'm going to set up my project. The first thing I want to do is use the npm init command. This will create a package file. You see here, it'll be here shortly, that contains information about the project. You can pretty much accept all of the default options here by pressing enter. Oh, actually, name cannot contain capital letters, so I'll make that lowercase. Enter to all of that. And yes, that's okay. So now you see I have a package.json file created. And I could have done that from scratch, but it's pretty easy to just do it using the npm init, which does it automatically and makes sure that it's created correctly. Next, I want to install the dependencies that my app will need. So for now, I'm only going to need to install Express, because if I run this right now, my app will not work. I'll actually demonstrate that. So to run a Node app in the command line, I use the node command, and then the name of the file that I used here that's called my main file, which is server.js. So I'm just going to use the name of that file. I don't have to put the JS extension. So I'm just going to put node server, press enter, and you see it cannot find the module express because I haven't installed that for this project. So to install a module, you can use npm install. And when installing something that you want to save to the package file for your project, when you know your app needs that module, you should use the -- save option. So I'm going to do npm install save express, since that's the name of the module I'm installing. Wait for that to complete. And now you see a node modules folder was just created here. Express will be in there. So that's done. And now if I try to run my server again, I get the message that I logged that says server is running on port 3000. And now you can see it's still running. It's still waiting for something to happen. So the next thing is to be able to respond to requests from clients. And if you remember, we have the different HTTP request types that clients can send. Those are the GET request, PUT, POST, and DELETE. GET is the most common. GET is when a client is asking for data or a resource from the server. So every time your browser requests a web page, that is a GET request being sent to the server asking for that web page, those files for the web page. So the HTML file, the CSS file, the images. Those are requested using a GET request. So that's the first one we'll handle since it's the most common. I'll use Control-C to exit to close my server for now. So in order to respond to requests, we create routes in our app. And that is just routing those requests to be handled appropriately. We do this using Express with the following syntax. We use app.get or whatever request we're handling. First, we need to identify which route we expect this request to come into. So we can create an API so that requests are sent to the right path on our server to be handled appropriately, because there are different types of GET requests that will come into our server for different types of data. If you think about a complex app, like a banking app, for example, the client might be requesting a login page. They might be requesting an account page. So we need to identify what exactly is being requested and handle that appropriately. So in this case, I'm just going to put a /, which means get the roots path. And that's usually like the index file of an app or the home page. After identifying which path I want to handle, I then provide a callback function that is called after this request comes in. And this is where I specify what should happen with this request. It has two parameters, request and response. And here I can use those if I need to, but for now I will just log a message. Or actually this time I will respond to the client with the text hello world, just so that we can follow through and do hello world with each of the new languages we're covering. So response.send, and I'll send the text hello world. So now when I get a GET request that comes into the root of my app, I will respond with hello world. So let's see what this looks like from the client side. First, I have to make sure my server is running so that I can listen to these requests. I'll run it again. So it's listening right now. And now I need to send a request from my client. So in this case, the browser can send a request to my server, which is running locally on my computer. Although normally, once you deploy your app, it'll be running somewhere on the internet that's not on your computer. So here I'm going to open my browser. If you remember, I specified that my server should run on port 3000. And I see the text hello world. So my server responded with that text to the client. So now let's do a route that's more appropriate to the app I'm working with. So remember, the main data that we want to work with for this app is comments. And each comment has a name associated with it and a comment. So if you imagine our database that we'll get to soon will store a collection of those comments and names, and then our routes will need to listen out for requests for those comments and respond with them. So let's create another GET request, and this time we'll put it to the comments path, which I'll create, and in this case I'll just respond with a list of those comments. Right now I don't have that list because I don't have the database set up yet, so for now it's good to either log a message. I'll say request, get request received at the comments path. And I'll just do that for now so that we can fill that in later once we get to the database. I can also do the same thing with a post request, which will be, a post request is when the client is sending data to the server. So most commonly a post request is sent from a form where once the user submits the form, all the data in that form is sent over to the server to be processed. So I'll do a post, and this will handle once we have the user submit a comment. And I'll just get these set up so that we can work with them in the next module. So that's really the core functionality that we'll program for our web servers in this case. We will simply set up routes that will handle the functionality that we expect and the requests that we expect from our clients. And then within these methods in the next module, you will write code to pull data from a database and then return that data back to the user. Or in the case of a post, you will write code to accept data from the client and insert that data into the database. So that's the basic functionality of our web server for now, and we'll talk more and extend this code in the next module. So to summarize what we've covered in this module, we talked about server-side web programming and what functionality our web server provides for our web apps. And overall, that functionality revolves around listening for HTTP requests from clients, and we do that by defining routes on our server that handle requests to different paths and using different HTTP request methods. Once we receive a request, we program our server to carry out any application logic that our app needs, and we communicate with the database to access or modify data. We haven't covered the database part of that just yet, but that'll be easy to fill in once we get to the next module. The framework that we used in this course for our server-side development is Node.js, and that allowed us to write JavaScript code that runs server-side when JavaScript code typically is run client-side. So that's a plus. And the framework we used on top of Node was Express. Now this course just covered the very basics of server-side programming using Node, but I do have a course on edX.org called Building Functional Prototypes Using Node.js. And in this course, you can get more hands-on instruction, practice, and assessments to help solidify a lot of the topics that we only touched on quickly here. So once you finish this course, if you're still interested, go ahead to edX.org and search for this course or follow the link that you see here. Welcome back. At this point, you should be able to create a pretty functional web app. You can create a web user interface using HTML, CSS, and JavaScript. And we talked about how to set up a basic server that can store and return information to clients. In this module, we'll fill in the gaps by learning how to store real data in a database and how to access that data from our app. So by the end of this module, you should be able to create a fully functional basic web app. So let's take a look at databases and what exactly they are and how they store data. So a database is something that stores a structured collection of information. And that can mean a lot of different things. You see some images here. You could just store that information in a text file in a structured way using commas to separate different types of values. You could store that information in object form where you have a key and a value for each property of your data. You could store that information in tables where the columns label the properties. There are a lot of ways to structure this information, and each of those could be considered a database. But overall, the things that all databases have in common is that they make it easy to access and manage the data that they store. And in general, the way that we access that data is using the CRUD operations that we've talked about earlier in this course, creating data, reading data, updating, and deleting. And we do that using query languages like SQL, which we'll talk about in this course, that allow us to write queries and statements in a structured language that are executed on the database. So I mentioned a few different types of databases on the previous slide, and the one that we'll be focusing on in this course is relational databases. So in relational databases, we store data in tables. Each table represents some entity or object of data. So in this case, you see a table that has a list of contacts. So the name of this table could be contacts, and that's an entity that makes sense as a cohesive set of data. The key about relational databases is that you likely have multiple tables of data, and they have meaningful relationships between them. So in a contacts application, you might have contacts, and you might have a separate table that has phone calls, and those phone calls are linked to contacts because you need to track who's making those calls, for example. So within each of these tables in a relational database, each row is a record of data, so one instance of data, and each record has values that correspond to different properties that we care about for the data. So in this case, some of the properties or attributes that we are tracking for this table are first name, last name, email address, phone number, and zip code. And as I mentioned, the primary functions that we want to perform on our data include those CRUD functions, creating data. For example, you might create a new table, you might insert a new record into a table. Reading data, you want to pull information, so you might ask or query for the phone number from the contacts table of a certain record, or a list of contacts that live in a certain zip code. We might want to update data, so change an attribute on a specific record in our table, or even delete a record or a table. The language that allows us to do this, or that we're going to be using in this course, is called SQL. This stands for Structured Query Language, and it's a language that provides a way for us to perform these operations on our databases. So the primary SQL commands that are most used fall into three categories: creating, inserting or updating, and retrieving data. So to create data and using SQL commands, these are a few of the commands that we use: the create, alter, or drop. Create will be used for sure to either create a table. And then in the insert and modify category, we have insert, update, and delete, which are pretty self-explanatory. We use insert to create new records within a table. And then we have retrieving, which is used very frequently to pull data from a database. So that is the select keyword, which we'll see very often. Now, we need a place to write or run this SQL code, and for that you use a database management system. Some examples of database management systems are SQLite, SQL Server, MySQL, things like that. The one we'll be using in this course is called SQLite, and it's a lightweight database management system for relational SQL databases. So what this is used for, this is a tool that will allow us to easily create and manage our databases, and provides a place to execute SQL commands using those commands we just talked about on the previous slide. There are two ways that you can do this. First, once you install SQLite, it comes with a command line interface, so you can use your command prompt to run SQL commands to work with your database, and that's a manual process. So that's good when you want to practice or set up your database, but that won't scale for your app. So once you're writing your code for your actual web app, you'll want to write code in your server-side language that will communicate with your database directly through SQLite. So that's what we're going to be doing for our web app. We're going to learn how to write JavaScript code that works with our SQLite engine to connect to our database. And before you can do the things that I will demonstrate in this module, you will want to install SQLite from their website. So now I'll transfer over to a demo where I'll show how to set up a database and how to hook up your database to your Node web app. So this is the web app that I left off with in the previous module where we set up a basic Node server using the Express framework. So we have just some placeholders within each of these routes that we defined, and in this module we'll learn how to write the queries that we need to connect these routes to our database. So the first thing I'm going to do is set up a folder that will store our database within our project folder. So I'm going to create a new folder called DB, and that's where I'm going to put my database file, just to keep everything organized and get set up with a good structure in case you scale and your project grows. Next, I'm going to create a database there in my command line using SQLite. So I'm going to navigate into that folder, and now I can just use a SQLite 3 command, and this will run SQLite in my command prompt. If I don't put anything else with this command, it will run with a temporary database that's useful if you just want to execute commands and practice, and that won't be saved when you're done. So instead I want to give a name of the database, and that will save the database once I exit this command prompt. So I'm going to call this, in this case if you remember, I'm storing comments in this project, so I'll call this database comments. And then I need the .db extension. So now I'm in the SQLite command prompt, and you see it's waiting for me to enter commands. The first thing I'm going to do, I've created a database, but I haven't created any tables within that database. So a database, a relational database, can have multiple tables, and often does. In this case, we're just going to create one table to store our comments that users input. So I'm going to use the create command. Notice that you typically write these commands in uppercase letters. That's a style convention with SQLite, with SQL, I'm sorry. So I'm going to create table, and I'll call this comments as well. And now I give the schema for the table, so what columns I want this table to have, and what type of data should be stored in each column. So the first column is just going to be titled name, since I'm storing the name of the user who wrote the comment. And next I give the data type of that attribute. So I cannot type. Give this is for a character sequence of variable length. So it can be not a fixed length string. And I'll do the same for a comment. So this is 2 strings that I will store in the database. So I'll just have those 2 columns. And then I end every SQL instruction with a semicolon. Now I can use the .tables SQLite instruction to see what tables I have. There you see the comments table was created. But right now it's empty, so I want to insert something just to test it out. I will insert into comments because I want to insert it into the comments table. And then the values, I will pass those values in. So I'll do my name, and I'll say this is a test comment. And now don't forget the semicolon. So I should have inserted a row into this table. So let's see if that's the case. Now I can use the select query to query for data in my table. So I can select certain rows of data, certain columns of data. The select keyword can be used in a lot of different ways, but for now I'm just going to use an asterisk. That means I want to select all columns from this database. And since I'm not using any additional clauses, I'm also selecting every row from the database. So from the comments table. So select star from comments means select everything from this table. And now I see that record that I inserted just now. And notice that this vertical line separates each of the properties of the table. So that's all I'll do for now. I have the table set up and I have one test row inserted, so I will exit this using Control-C. And from now I will work in my project file to hook up the app to this database. So the first thing I'm going to do is install the SQLite 3 module for my Node project. So I'll go back up one folder into my the root of my project, and I will do npm install SQLite 3 so that I can use this module in my Node app. Wait for that to finish. It's taking a while. Okay, so that is done, and next I'm going to import that module in my project file. So I will create a variable to hold that instance and require SQLite 3. And next I will link to the database. And I've created that database. Remember, it's in this DB folder called comments.db. So I'll point to that. Okay, so now I can use this database in my code. So the next thing I want to do is, instead of having just logging to the console when I receive a request, I actually want to fulfill the request. And these requests all deal with data. So let's start with the get comments route. So in this case, I just want to run that same select statement that I just ran in my console to select all the comments that I have in my database. So to do that in Node, I will use my database object that I created here called db and the all method. So db.all, and the first thing I pass in is the actual SQL command I want to run. So I will write select all from comments, just like I did in the command line, and then I pass a callback function to execute afterwards. And this accepts an error argument and a rows argument. And if everything goes well, then rows will contain the actual rows of data that we retrieved from the database. So in this case, I want to, if there's an error, I'll log that to my console. Oops. Can't type today. And if there's not an error, I will send those rows back to the client. So I'll use response.send, just pass those rows back to the client. Okay, so let's talk about how we can test this. I didn't cover jQuery in this course, but I will quickly show some code that I have that sends a jQuery request to this path and expects that data back. So in this script file, this is a script.js file that's on the client side of my app. So this runs in the browser. And here I'm sending a request to the server to that same comments path that we just defined on the server using a GET request. And this is being done with jQuery, so that's what that $sign is for. And then I have a callback function that once we receive that data, I display it on the page appropriately. So I won't go into this because this module is focused on databases, but this is the code that is sending the request from my client and then rendering it on the page in the way that I want. And you can see that this is just pure JavaScript down here, creating new elements, putting them on the page, and displaying the data that I got from the database. So now that I have that, and I think everything is hooked up on the database for this GET route, I will test it out. One thing I should mention actually is I need to actually hook up, specify that my client-side files are all in this public folder, and that when I access anything in the public folder, it should be served as is, as a static file. So that allows us to return files directly without doing any scripts or modifying them. And that's what we want to do for our HTML, CSS, and JavaScript files. So to do that, I'm going to use Express and set up a static route. So I'm going to use the app.use, and then I'm going to pass in express.static, and I'm going to give it to the path to where my static files should be. And that will be this public folder that I created. So I need to give this a full path, so I can use the dir name, which holds the directory that my files currently live in, and then I will just add the public folder to the end of that. So now when I try to access these files on my server from the client, I should be able to access them directly from the server. So I'll go over to the browser. Before I go to the browser, I'll run my server so that I can test this. Node server. It's running on port 3000. So now when I access demo.html on my localhost path on port 3000, I get the same demo.html file that I have in the public folder of my server code. And if you notice, I have the test comment that I just created in my database in the command line. So this is actually sending a GET request to my server and pulling that data back and presenting it on the page. So it looks like that's hooked up correctly. The second thing we'll do is work on the post, handling the post requests. And right now we're posting from the HTML file when the user submits the comments form right here. And we have it posting to this comments path using a post method. So let's go ahead and handle that on the server. Also, one thing to note, we're posting data. We need to pay attention to the names we gave each of these. So the name for the first one is name, and the name for the second one is comment. So those are the IDs we're going to use to reference each of these data, pieces of data when we receive them on the server. To handle this post data correctly from forms, we need to install a module called body parser. So let me cancel my server, and then I will npm install save body parser. So now that that's installed, I will include this module in my file, the same way I've done every other one. So var body parser equals require body parser. And I will make sure that my app is using body parser to handle URL encoded data. And in this case, I need to pass an option that says extended false. And this is to handle the form data from our that we receive from our HTML form. So now I can go ahead and write the SQL for my post route handler. So in this case, I want to insert the data that we receive from the form into the database. So when someone types their name in a comment, I want to add that name and comment to the database table. For the get request or the select statement, we use db.all. In this case, for an insert, we're going to use db.run. All is used for querying. Run is used for other types of SQL commands. Now I'm going to insert the command, and I'm using an insert statement since I'm inserting data. Insert into comments table, and I'll pass the values. And in this case, since I'm using dynamic data in my command, we use placeholders. We use question marks as placeholders for the values, and then we pass another parameter afterwards with that dynamic information for what values we want to insert, since that's changing all the time. So the values in this case, what body parser allows us to do is get the information that was sent from the form in the HTML, the HTTP request body, and reference that from our JavaScript code. So I can use the request object, which I have right here, and I'll do request.body. And remember, the name of that field for the name was actually called name in my HTML code, and then the second one was called comment. Now, these two values will replace the two question marks in my insert statement. So we're essentially inserting the name and the comment into the table. And then we have a callback function to handle any errors. In that case, I will just log the error. Otherwise, I will send a status back to my client. I'll send a 200 status code, meaning everything's okay, and then I will redirect back to the demo.html page. So everything looks good here. Actually, I forgot semicolons here. Luckily, that still worked. Okay, so I'm going to run my server again. And this time I will send a post request and see if the data is inserted into the database. So I will type a test name, and I'll just paste this placeholder comment and submit that. And we see it was automatically updated because our page is sending that GET request every time we refresh. And since the page redirects after our post request, that causes our script to run again and send a new request to get the latest data. So we see that now our page is using dynamic data from our database. And all we did was create two simple SQL statements in our routes in our Node app. And now everything is hooked up end to end. So really, it's as simple as setting up your routes in your Node app using Express, and then using the SQLite module to set up those SQL statements that you want to run for each of these routes. And then on the client side, use JavaScript and jQuery to, where's my script? Use jQuery to send AJAX requests when you need to use a GET request, and then you can just render the data however you want using pure JavaScript or using jQuery. And then for sending a post request, that happens automatically with your form once you specify the method type as post in your form. To summarize what we've covered in this module, we talked about databases and how to store app data. Databases are a collection of data that's stored in a structured manner, which makes it easy to access and manage that data using CRUD operations. And SQL is a query language that we use to access and modify data. SQL has commands that we use that correspond to the CRUD operations that we want to do on our data. And SQLite is the database engine or database management system that is a tool that we use to execute these SQL commands that we write to operate on our database. Finally, when it comes to hooking up our Node apps to a database, we write our server-side code in our Node app using JavaScript that uses the SQLite module to execute those SQL commands on our database, and that completes all of the functionality of our server-side web app. So from there, our app is all hooked up and functional, and once you write that client-side JavaScript code using JavaScript and jQuery to send those requests to your server, you should have everything hooked up end-to-end, and your app should be using real dynamic data from your database. This was a brief demo of these topics. I know I didn't go into detail about everything, but if you're interested in learning more, go ahead and take my edX course on edX.org called Building Functional Prototypes Using Node.js. And in that course, you can learn a lot more about this topic, along with more instruction, assessments, and assignments so that you can practice and work along as you learn. Welcome back. Now that you know how to create a web app from start to finish, let's make sure that you can share your work with the world by hosting your app online. In this module, we'll talk about Azure App Service, which is a platform that allows you to publish your app to the web for other people to access. Let's get started. So let's first talk about what Azure refers to. So Azure is a cloud services platform, and that can mean a lot of things. Azure offers a lot to developers and IT professionals, but in general, the categories that all these services fall into is that Azure helps you build things from web apps to IoT solutions. There are a lot of different technologies that Azure works with. Azure helps you deploy those products, and then after they're deployed and up and running, Azure is useful for the management and analytics of how those apps are performing, and any other insights that you want to analyze about your application. All of these services are accessed through the Azure portal, and you can access that at portal.azure.com. So let's talk a little bit about how to deploy to Azure App Service. So Azure App Service is the service we're going to focus on in this course, since we're focusing on deploying our apps. But as I mentioned, there are a lot of other services that you can take advantage of with an Azure subscription. Azure App Service in specific will host your application online. You don't really want to have your code running on your own machine and have people having to send requests to your computer. You want a real server to be running your app so that other people can access it online. So Azure provides that. On that server that Azure will host your app on, Azure will maintain the application framework that you're using, which in this case for this course is Node.js, but Azure works with many others, including ASP.NET, and other technologies. And beyond that, Azure has a lot of other services related to the Azure App Service, including maintenance, source control for your source code, app insights, and a lot more. So there are a few ways to deploy your app to Azure App Service. And deploying just refers to transferring your application files and resources to an Azure hosting instance. The most direct way is FTP, which stands for File Transfer Protocol. And with FTP, you can use an FTP client to directly upload your files to your Azure directory. The way that is recommended for this course is using a repository. Earlier in this course, we talked about setting up a Git repository as well as setting up a repo on GitHub. So you can use either of those repos to deploy your app. If you deploy from your local Git repo, then you will have to manually sync your app every time you make updates. Or you can deploy from your GitHub or any other cloud repo like Visual Studio Team Server. And in this case, you can continuously deploy automatically every time you make updates in your repo. And then the third is an option called Web Deploy, but we'll focus on the repository option for this course. So a lot of these things are really straightforward, and Azure provides really in-depth documentation that they keep up to date. So the next steps that you'll want to take when you're ready to get your app up and running on Azure, if you choose to do so, is to first create an account and choose a subscription. They do have a free account option, and you can read more about that at the link I've listed here. Next, you'll want to deploy your app using one of the options I talked about on the previous slide. And then once you have your app up and running, you can take advantage of the Azure App Insights. So that will allow you to analyze different metrics about how your app is performing, how people are using it, and things like that. So that's really fun to do. And it really lets you know that people can access your app from anywhere, and you can really have impact developing for the web. So I encourage you to take advantage of Azure for hosting your app and share your app with the world so that people can access it and you can really fall in love with web development and the impact that you can have. Congratulations, you've made it to the end of this course, and you should be equipped with the knowledge to build a basic web app from start to finish. Let's recap what we covered. So we started with talking about how to identify what you're building and plan out who you're building something for and what needs you can address. Then we talked about how to build web pages using HTML, styling web pages using CSS, manipulating web content using JavaScript, and then we moved into back-end web development concepts. So we talked about how to build web APIs using Node.js, storing data with a basic database, and then finally deploying your app using Azure App Service. Now, these are a lot of topics, and we didn't cover each one in detail, but hopefully you've learned more about each of these and understand how they all work together and what you need to learn. And hopefully you have a fundamental understanding of each of these concepts at a high level. But if you want to continue learning from here, we do have some suggestions. We have a few courses on edX that cover similar topics, but in a lot more detail. So in this course, we didn't really give you any practice, we didn't have assessments, but on edX, we do have more thorough courses that will give you a more hands-on approach. So one course is Designing a Technical Solution, and that covers our design, user-centered design, HTML, and CSS. We have another course called Building Interactive Prototypes Using JavaScript, where we go deeper into the fundamentals of programming with JavaScript, and we talk about client-side development. And then we have a course called Building Functional Prototypes Using Node.js, where we talk about the back-end web development concepts and servers, and as well as deploying on Azure. So we'll link these courses in the resources for this course. And I encourage you to take advantage of that and go deeper into the topics that we covered here. The best way to learn is to practice. I truly hope that you enjoyed this course as a first look into these topics and wish you luck with your continued success with these topics. Thanks.